there's nothing around. Just the eternal, endless whiteness of Greenland snow and cold winds blowing into your face. Nothing hints at the impending catastrophe. You take another step and freeze in horror. An abyss is spreading at your feet, bottomless and dark. If you had made a bigger step, it would have swallowed you. That infamous Greenland's hole. It happened in the middle of the 2010s. A group of geologists were scanning the surface of Greenland's Hiawatha Glacier using radar when they spotted something very, very strange. It was a giant pit, more than 980 feet deep and almost 20 miles wide. That's big enough to fit inside Washington, D.C. or Paris. After staring at their radars for quite a while and scratching their heads, researchers decided to find out what could have made such a huge hole. Could it have been good old erosion? A raging volcano? An asteroid impact? A giant sandworm? Ugh, I might have gone a bit overboard with this worm idea, but you never know with these ancient glaciers. Anyway, in our case, one mystery seemed to lead to another, which had been puzzling scientists for decades. And to solve both of them, scientists needed something super common, but at the same time very important. Quartz, one of the most abundant materials in Earth's crust. But before we dig deeper into this topic, let's make a small detour and talk about a pretty bizarre phenomenon called the Younger Dryas event. To see what it was like, we need to go deep into the past. As far back as 12,900 to 11,600 years ago. During that period, the planet became much colder, especially in Europe and North America. Now, let's talk a bit more about that weird climate change in the Northern Hemisphere. There are a few theories. One that involves a change in currents in the Atlantic Ocean. Another speaks about something large kicking tons of dust into the air and effectively blocking sunlight. The two most popular and likely hypotheses mention a volcanic eruption and an asteroid impact. Indeed, there was a volcanic eruption on the territory of modern-day Germany at around the right time. But there's also a probability that a space object struck the planet during this period too. And now let's get back to the hole scientists found in Greenland. When NASA's Ice Bridge program and Germany's Alfred Wegener Institute discovered it, it seemed they had finally found the reason for the Younger Dryas event. But was it really an asteroid that created that impressive pit and caused temperatures to drop all over the Northern Hemisphere? To test this theory, the researchers needed quartz. The thing is, in its pure form, quartz has a very simple structure. It's made from interlocking silicon-oxygen tetrahedra. Efficient and so pretty. Just look at these six-sided prismatic crystals. Since its structure is so simple and the components are so common, you can find quartz almost in any rock on the planet. At one point, magic happens. Larger rocks erode away, pushing out tiny bits of quartz sand. The scientists exploring the mysterious pit gathered the quartz sand that had been washed out from underneath the glacier. It was like looking at the rocks at the very bottom of the hole without having to actually get all the way down there. Very handy. So while examining the material, they discovered quartz grains with the telltale signs of terrible catastrophe. They had PDFs all over them. No, I'm not talking about the document format. PDFs stand for planar deformation features, and they look like lines etched into the crystal surface. These lines are a sign that you're holding shocked quartz. It forms under immense pressure, when the internal crystals are pushed out of alignment. But the most exciting thing here is that shocked quartz only appears under the influence of powerful forces, like massive impacts or terrifying explosions. In other words, finding this poor shocked quartz under the Hiawatha Glacier could be much needed proof that the hole was an enormous impact crater that formed when something equally enormous crash-landed there. Based on the size of the crater, this space object probably was a bit more than a mile across, which is twice the height of the Burj Khalifa Tower in Dubai. A meteorite that big would have looked 3 times as bright as the sun when traveling across the sky, and it would have hit Earth with an immense force. The impact would have been so great it'd have vaporized rock and thrown debris for hundreds of miles away. The sky would have filled with dust. It would have dimmed the sun and led to a temperature drop all over the planet. And guess what? The last part about decreasing temperatures got the researchers super excited, because it opened up a possibility that the impact could have been connected to the Younger Dryas event. To prove this idea, scientists decided to use quartz again. They examined it more closely, trying to date the impact. Well, they were in for an even greater shock. The Hiawatha crater turned out to be not 12,000, but 58 million years old. On the other hand, the researchers were disappointed that they hadn't been able to confirm their theory. The crater couldn't explain the Younger Dryas cold snap, but on the other hand, it was still an amazing discovery. Now, get ready for one final twist to this story, and it revolves around quartz again. Other scientists have recently discovered more deposits of shocked quartz all over what is now the eastern USA. It was hiding in sediment layers dating to just before the Younger Dryas. Interestingly, there aren't any craters around those sites whatsoever. But quartz can't lie. It provides evidence of a powerful explosion. It makes scientists think that their impact hypothesis might still be true, but instead of a collision, it could be an airburst. A massive comet could have broken up while entering Earth's atmosphere around 12,000 years ago, and the fragments could have exploded before reaching the ground. It would have caused catastrophic mass burning throughout the North American continent and messed with the climate so much that the Younger Dryas would have been triggered. Well, I guess we need to wait a bit longer for scientists to find some further proof of this hypothesis. But it doesn't mean we don't have any more curious phenomena to explore in Greenland. Take these fascinating holes. They sure are kinda smaller than the monster we were talking about. They're called moulins, and they carry surface meltwater all the way down to the base of the Greenland ice sheet. And they have prepared some surprises for us too. Apparently, they're way larger than we previously thought. That's what a recent study based on observation and first-hand exploration claims. Even more interesting, this high volume might influence the stability of the ginormous ice sheet in question, as well as the speed at which it's sliding towards the sea. Researchers think that increased water depth and pressure inside moulins might lubricate the base of the ice sheet, making it move faster. You know, the way an ice cube slides more easily on a thin film of melted water. Until recently, we knew too little about the real size of moulins and how much water they can hold. But now, we know that moulins can be giant. The team made 2 trips to the Greenland ice sheet in 2018 and 2019. And during each of them, they used ropes and climbing equipment to drop around 330 feet into 2 separate moulins, almost touching the water's surface. Those who did it described the experience as intimidating. Picture this. Your back is over the edge. All you see is bluish ice going down and blurring into blackness. And the only thing you hear is occasional sounds of crashing ice. It must be extremely unnerving.
There's not much to do in Antarctica except scientific work. You could check out the wildlife, like some cute penguins and seals. And you'd get to see the occasional whale swimming around. Antarctica is one of the biggest lands out there that's only inhabited by scientists and researchers from all over the world. These scientists dug a hole through some pretty thick ice to study the ancient air and how the atmosphere cleans itself. They used a special drill and dug a clean cylindrical hole 450 feet below the surface. Some of this ice can be up to 800,000 years old and is a good indicator of what the climate was like in the past. It's like checking out tree rings to determine how old a certain tree is, except it's more complicated than that. After the effortless digging, they decided to drop some ice to the bottom of the hole to see what would happen next. They heard some really unusual sounds. It felt like being on a spaceship traveling through a bunch of obstacles with many rocks smashing into each other. The pitches changed over the quick descent of the block of ice, ranging from high pitch and ending with a low heartbeat-like sound. The scientists were puzzled when they first heard this and dropped some more ice, only to find out that the same type of sounds were being produced, just in different variations. They couldn't tell what was down there and, more importantly, why these kinds of sounds were produced. Antarctica boasts quite a few volcanoes, many of which are under super thick sheets of ice. Scientists discovered 91 volcanoes and claimed there could be more, potentially making it the most extensive volcanic region in the world. While they were doing regular scientific research, they came across many unmistakable large cone-shaped figures underground. Some were as deep as 2 miles in the ice. Some of the peaks were over 3,000 feet tall and dozens of miles across. But on the surface, it's as plain as a sheet of paper. They may have dropped that block of ice inside an actual volcano that they were standing on, but it's unlikely. Even though the underground volcano presence was discovered by accident, there's a small chance they were actually standing on one where they had their workstation set up. It's more likely that they worked in an area where studying ancient climates is easier and less dangerous than other places. They collect ice samples and study them in a lab. It's like discovering a prehistoric insect embedded in amber millions of years ago when dinosaurs used to roam the land. But instead of little bugs, scientists study ancient dust, air bubbles, sea salts, volcanic ash, and anything else that may have come from the environment. They can practically tell how the climate was during that time. These ice samples might show that Antarctica's western ice sheet melted when the Earth's climate warmed up. If it did, then it's likely to happen again. That would mean sea levels rising, affecting coastal cities and small remote islands. But scientists aren't sure it's true, despite some evidence to back it up. The process of studying ice samples can take a week or even a year, depending on what they find. They crush or melt the sample bit by bit. And like those tree rings, the deeper the layer, the further we go back in time. In order to study ancient bubbles trapped in ice, researchers have to crush the samples under a vacuum hood to keep the air out while extracting the air and putting it in vials. There are various instruments and devices to study the ice samples, but because it's so sensitive to damage, each measurement must be in a clean room setting so that nothing gets compromised. The scientists have to wear proper bodysuits and many layers of gloves and constantly get ventilated. Even something as tiny and insignificant as a fingerprint can ruin a sample. They look for certain patterns to see changes in the atmosphere's composition and temperature. But dropping a few blocks of ice down a hole wouldn't be so bad. The reason why it made such a peculiar sound is the same reason why a moving car sounds different when it's honking than when it's stationary. The scientific word for it is the Doppler effect. It's an obvious change in the frequency of a wave with respect to an observer who is moving relative to the wave source. The effect doesn't mean the frequency of the sound changes, it just shifts. And this can be said about other types of waves, like water and light. But sound waves are the most popular ones when it comes to the Doppler effect. So, when the scientists dropped the ice block down the bottom of the hole, the sound waves traveled back up and bounced around the narrow tube where they drilled. That's why they got the pew pew sound. Let's not forget that this ice block traveled 450 feet beneath us. Oil ships dig holes in the oceanic crust that go thousands of feet beneath the Earth. The Kola Super Deep Borehole in Russia is the deepest hole ever made by humans. It goes more than 40,000 feet below the surface and took almost 20 years to reach 7.5 miles. Below it is only half the distance to the mantle. In terms of the whole Earth, this very deep hole is literally scratching the surface. This wasn't a hole to dig for oil, and wasn't in the ocean either. The drilling was stopped in 1992 when the engineers found out that the temperatures were 100 degrees Fahrenheit higher than they predicted. And then it was abandoned, and it's just been a barren hole now. But that's the closest we've dug to the center of the planet. The scary thing is that some of the workers on the site could hear voices coming from within. All the way in Yemen, an ancient hole exists in Barhout, in the east of the country in the middle of the desert. It's actually closer to Oman than to the capital Sana'a. This hole has puzzled experts and locals. Unlike the holes in Russia and Antarctica, this wasn't man-made. Or was it? It's been around for many years, and the locals try to steer away from it. They don't even like talking about it, since they claim it brings bad luck to those around it, or to whoever utters its name. They claim it was created as a prison for spirits, but many rule that out. The hole is 98 feet wide and somewhere between 330 to 650 feet deep. You can also hear strange sounds coming from the inside. But according to some scientists, the well has little to no ventilation and barely has any oxygen down there. So it's unlikely that anyone or anything lives down there. The Challenger Deep in the Mariana Trench caught some low-pitched grumble sounds in March of 2016. Some of these grumbles were followed by screeches. They caught these sounds in a span of weeks, using a titanium-encased microphone so that the immense pressure of the lowest point on Earth wouldn't crush it. They had to lower it slowly as well, since it's 1,000 times the atmospheric pressure at sea level. For 23 whole days, the microphone recorded typical sounds of whales passing by and boats sailing across from above, and even rumbles of nearby earthquakes, but they still couldn't determine what caused those initial sounds. The researchers couldn't understand if the noise from the bottom of the Mariana Trench was caused by humans or was natural. They also wanted to know if these sounds affected marine life, like dolphins and whales that rely on echolocation. They still can't figure it out, but scientists estimate that the ocean is about 10 times noisier than it was 50 years ago. With technological developments in shipping, submarines, and underwater construction, the ocean will only get louder with time. Northern lights come with sounds, which nobody talks about. They're usually audible when the auroras are at their most powerful presence. Scientists were always puzzled as to what caused the faint popping and crackling, even though they were very far above us. They used some special microphones and found out that the sounds came just 230 feet above us, which is pretty low. They're caused by electrical charges gaining power in a specific region of the auroras. The electrical charges are disturbed by magnetic storms that fire up the northern lights. As a result, some tiny sparks are released into the atmosphere, causing the faint crackling and popping noise. Could there be a place on Earth that could take you to another dimension? In 1997, a phone on an American radio show rang. The employee picked up the phone and got probably one of the most unusual calls in his career. A man on the other end of the line introduced himself as Mel Waters. He started a story about how he discovered a pretty unusual hole on the rural property he owned that was near Ellensburg, Washington. I used a fishing line and a weight to measure it. According to my calculations, it's 80,000 feet deep, Mel claimed. And some weird paranormal things have been going on here. He was talking about a black beam that could come out of the hole and shoot into the sky during certain day periods. He believed the hole had magical powers, like restoring life in animals and allegedly setting ice on fire. Yep, the ice in question didn't melt. It burned like coal. The call went public. Mel managed to convince many listeners his story was true. One geologist, named Jack Powell, was especially interested in the story he had heard on the radio. He found it somewhat curious, particularly because Mel claimed it was basically the bottomless pit. Jack was in geology for decades, and he was familiar with the fact that the deepest shaft goes a bit over 40,000 feet below the surface. Jack started to investigate that mysterious case, but no matter how hard he tried, he couldn't find the hole. Further investigation led to the fact that they later couldn't even find a person named Mel Waters that lived close to Ellensburg, Washington. After the phone call went public, the mysterious Mel even claimed some tried to pay him off to stop talking about the hole. This whole story became an urban legend. Later, many people claimed they found that hole and saw weird things happening there. They heard strange noises coming out of the hole. Others saw lights and unusual creatures coming out of the hole, and some believe the hole goes all the way down to the center of our planet. whereas others go so far to think it's a secret portal to another dimension. A few people think Mel's Hole is a spot where space and time are warped. People or objects that enter it never come back, and no one sees them ever again. Of course, those are all just different theories. After all, no one still knows if Mel's Hole even exists or not. That deepest hole in the world we've mentioned before, the one that actually exists, is called Kola Super Deep Borehole, and it's human-made. It's covered and welded shut, and it sits among the abandoned ruins of one project site. It took people who made it around 20 years to reach that many miles under the surface. What stopped them at such depths are 2.7 billion-year-old rocks. They were at temperatures of about 356 degrees Fahrenheit, which was almost twice as hot as the team thought it would be. A hole this deep may seem like something from horror movies, but here's something that will comfort you. It's just 9 inches in diameter. That means you can't just wander around and accidentally fall inside of it, which, you have to admit, makes it a bit less scary after all. But many locals are still very afraid of it and are not comfortable with this hole. Many of them claim they hear terrifying screams at night coming out of it. If you decide to enter Krubera Cave, one of the deepest ones on the Earth, know that it could take days or even weeks to reach the bottom. This massive cave complex is located in Georgia, and it goes over a mile under the surface. It even got the nickname of being the Everest among other cave systems. The cave system looks really scary. Imagine going down there. But it's also home to a fascinating diversity of wildlife. There's also a basin filled with water at its bottom. The Berkeley Pit is a toxic hole. It's a former open-pit copper mine located in the western part of the United States. The hole is a mile long and half a mile wide. It's 1,780 feet deep, which is taller than the Empire State Building, and nearly half of it is filled with heavily acidic water. It has a similar level of acidity to gastric acid or lemon juice. This pit is full of dangerous chemicals and heavy metals. The water at the surface is red because of all those heavy metals that float around, like breadcrumbs in this poisonous soup. This soup has ended the lives of many birds that tried to land in the water at some point. If you want, you can even go there, pay the ticket, and check the pit out from a safe distance. It's a perfect day. It's not cloudy, the sun is out, and you're in the tropics, swimming in the sea. The water is crystal clear. So clear, it seems like you could see the bottom of where you're swimming. You look down and all you can see is darkness. The bottom is deep down below you, and if your imagination runs wild, you'll see giant sea monsters coming from down there right away. And that's how it feels to be above Dean's Blue Hole. It's nearly circular at the surface, but if you dive a bit deeper, it suddenly widens into a 4 times wider cavern. It's located on Long Island in the Bahamas, and it goes 663 feet below the surface, which makes it the second deepest hole in the world. It's a sinkhole filled with salt water that has an entrance below the water level. Such sinkholes can form in different processes. For instance, when rainwater soaks through fractures of limestone bedrock directly onto the water table. And in the case of this pit, the sea level has changed too. It got higher compared to, let's say, the Ice Age from 15,000 years ago. This one is Mount Baldy Sinkhole in Indiana. It was a beautiful sunny afternoon. A woman named Erin was on Mount Baldy, just finishing her scientific study of wind speeds. She was happy with how things were going, but suddenly, a bad hunch erased the smile off her face. She turned around and saw a man in his swim trunks. He was desperately clawing at the sand. "He's right here!" he yelled, while his wife was near him, panicking and in shock. Their 6-year-old son had disappeared, simply vanished down a hole. Erin didn't see any sign of an opening. She saw no upturned sand, which you'd expect to see if a person had just dug a hole. More and more people were coming to help, and someone called 911. She couldn't believe that something like that could happen. She thought their son was just hiding somewhere around, waiting to jump out and surprise them. So she went home. But later, she saw it on the news. The rescue team had managed to save their son. They found him 11 feet under the surface of a dune, and it was a complete shock for her. We're in such an advanced era when the robotic arms of spaceships scoop sand on Mars and then tell us its chemistry. And here, you can take a simple walk to the beach and still end up surprised by such geologic mysteries, like a hole that appears out of nowhere. Ice Cube Neutrino Observatory looks like a hole you'd see in some scary science fiction movies. This Antarctic research station is located at the South Pole and 3 times as large as the world's tallest building. This enormous hole made of metal and ice is frozen and isolated, and it reaches depths of around 8,200 feet. Scientists hope to use it to understand neutrino particles better, and through that, learn more about dark matter. It's the mysterious substance that makes up almost 30% of the universe. No one can see it directly, but scientists assume it's there. They believe it affects the movements of stars and galaxies.
Wow, the great day is finally upon us. The record-breaking hole boring team is finishing their job today. Spectators have gathered from all parts of the continent just to look at the greatest borehole in the world, and even the Guinness World Records Commission is officially dumbfounded. The hole is more than 1,000 miles in diameter and goes almost as deep as the Earth's core. No one achieved this depth before. But wait, what's going on? People all around suddenly begin fainting. More and more of the spectators fall unconscious on the ground, their faces white. Did the diggers hit some dangerous gas pocket? Oh no! We're getting messages from all over the world that people start falling just where they stood. What in the world is happening? Ugh. So, this is the scenario you get if you dig a hole in the ground deep and wide enough to fit the whole atmosphere inside it. Let's explore. The atmosphere goes really high up, getting thinner and thinner the higher you rise. For example, on the ground level, you can breathe freely, while on top of Everest, you won't be able to survive for long if you haven't had a good training course beforehand. The air on the mountaintops is much thinner, and so it's a lot colder and harder to breathe there. If you rise even higher, say to the altitude where airplanes fly, you probably won't be able to breathe at all. That's because they have oxygen masks on board. If the plane loses its inner pressure, the air from the outside will rush in. And since it's too low in oxygen for your lungs, you're likely to lose consciousness very quickly. All that doesn't mean our atmosphere ends there. In fact, it goes far beyond. And some scientists say it could even include all the distance to the moon and even further. Oxygen molecules from the Earth's atmosphere can be found at massive distances. Although there are so few of them, you won't be able to use them anyway. And the furthest range the atmosphere goes is almost twice as far as the moon. But those are no more than tiny specks of hydrogen at that point. Now, if we somehow compress all this volume into a relatively small bubble around the planet, it would be about 6 miles above the ground, roughly the height at which commercial airplanes fly. Any higher, and there's big cosmic nothing called vacuum, where no airplane would be able to navigate. Next step, fitting this mass of air into a hole in the ground. For starters, the entire volume of our rather thin bubble is only enough to fit into a 1,000-mile cube. This is just a little smaller than the Earth's core, and a side of such cube is about a third of the United States east to west. And here's the first serious problem. No one has ever dug a hole that deep, or wide for that matter. The deepest human-made hole in the world is the Kola Super Deep Borehole, and it's only going about 7 miles down. The drilling stopped because of unexpectedly high temperatures. Drilling and digging, though, are different things. The Kola borehole is only 9 inches in diameter, while what we need is to take a supermassive chunk out of the Earth to fill it with air. Still, at about the same depth, we'll face the temperatures of around 350 degrees Fahrenheit, and the deeper we go, the hotter it'll get. The Earth's core lies at 1,800 miles. So, to dig that cube, we'll need to go more than halfway to the center of the planet, where the temperature will reach almost that of the Sun's surface. And that's not considering the time we'll need to dig that deep. Anyway, let's assume we have the equipment that can withstand such heat. As we go down, the air fills the pit and slowly leaves the atmosphere. And as it gets deeper, the pressure on it grows too, making it take less space. In the end, with all that weight from above, we won't even need such a deep hole, right? Nope. The high temperatures in the Earth's innards makes the air less condensed and compensate for the pressure. If the surrounding rock is hot enough, it will expand the air to such a degree where it will take the same amount of space as on the ground level. And when it gets even hotter than that, well, the air will actually take even more room than we've calculated. But we diggers aren't that easily daunted. The experiment continues with an actual 1,000-mile cube dug in the Earth's surface, reaching into the crust and mantle and almost to the molten core. The air expands from the heat and starts taking up more space, resisting its imprisonment. That's why we begin digging to the sides at lower parts of our hole. To compensate for the air expansion, the additional hollows span over 4,000 miles. That's about the radius of the planet. Finally, the air seeps down, leaving the atmosphere and filling the internal parts of the Earth. And still it won't stay put. Some of the air is yet on the surface, and everyone can still breathe, although it's becoming much harder. Turns out, to fill the pit with air, we'd need to dig so much that the Earth would just fall apart before we finish. But even now, the enormous hole we've made has changed the planet's center of mass, and is now spinning and revolving around the Sun more slowly and awkwardly. Instead of pushing all the air from the atmosphere down below, we've caused a cataclysm that would destroy our planet much more quickly than the lack of breathing air. Okay, so let's rewind then. We can't dig a hole in the ground because the air just won't fill it, but stubbornly spills out, and eventually our planet will just be torn apart. And we probably can't dig through the ocean's bottom because the hole will get filled with water instead, and the air won't have the room either. And that's not saying anything about all the water that gushes down to the hot layers of the Earth, causing catastrophic reactions that will, you guessed it, blow the world to pieces. If so much cold water reaches the extremely heated depths of the planet, hot magma below will start releasing toxic gases into the atmosphere, suffocating any life on the surface. Oh boy. So, the only chance to fill the hole in the ground we made is to compress the air to a liquid state, almost like they do with scuba gear. The oxygen tanks are filled with super compressed air that allows divers to breathe for a long time using just a small vessel. Now, we could just fill several 100,000 of such tanks with compressed air from the atmosphere and throw them all into the hole we've dug out. The pile will only be several hundred miles high, so technically it's not possible. Or we could invent a really huge tank for just this one purpose, pump all the air from the atmosphere in there, compress it as much as possible, and then dump it into the ground. Congrats! Mission accomplished! We've dug a hole deep and wide enough so that all the air around the Earth fits inside it. Now, what happens next is all life on the planet stops breathing. Humans, animals, plants, even aerobic microbes can't survive without oxygen. So everyone and everything is effectively wiped out. Then, no more oxygen means no ozone layer either. The lack of this natural barrier makes the planet extremely vulnerable to the sun's radiation and cosmic rays. The flares from the sun stop warming the Earth and begin scorching it instead. The surface of the planet rapidly becomes an arid wasteland, bombarded with heat and UV rays. Next goes tectonic activity. With the temperature outside spiking, volcanoes start erupting all around the world, making it a churning mass of hot lava. Oceans boil and evaporate, mixing with toxic fumes and creating a thick blanket of black clouds. Ash and acid fall from the sky, covering the already scarred Earth. And finally, our former blue and green planet turns into a twin sister of Venus, the unbearably hot and inhospitable place where no life is possible. Well, this would not be a smart thing to do. So please, let's not try this at home. You want a super big hole? Try the Grand Canyon. Ladies and gentlemen, your attention please. Alright, just listen up. The Guinness World Records Award for the deepest human invasion into the Earth's crust goes to the Kola Super Deep Borehole. Ooh. Its depth is 7.4 miles. You can find it in the icy part of Russia where the winter temperature of minus 40 degrees Fahrenheit is a common thing. Well, that's chilling. Local scientists started to dig it in the 1970s. The grand plan was to reach a depth of 9.3 miles. It was a purely scientific project to study the Earth's crust and maybe get to the hot mantle. Well, when it's so cold outside, it kind of makes sense. Up to the depth of 4.3 miles, the drill easily coped with granite rock. Then, denser layers came and broke the drill. The scientists had to change the drilling pattern. In the end, it resembled a tree with many branches. The deeper it went, the hotter it became. The temperature went up to 350 degrees. The equipment was constantly out of order and work was stopped completely in 1992. If you see this legendary place with your own eyes, you'd hardly realize there's an abyss right beneath your feet. The borehole looks like a rather small and unambitious hole in the ground. The place is now abandoned, overgrown with moss and rust. It has its fair share of myths surrounding it too. One of them says people hear strange sounds like moans and screams from the depths. In reality, of course, none of this is true. At the time, many countries were engaged in the study of the Earth's crust. For example, Germany. They duly noted the experience of the Kola borehole and made a super tech drill that could withstand extreme temperatures. A location was chosen in Bavaria at the junction of two tectonic plates. In the past, they were the shores of an ancient ocean. In the early 90s, a group of researchers began drilling a well there. But already at a depth of 4 miles, the Earth fought back. It deflected the drill from the vertical, and then the temperature made a surprise spike to 520 degrees. All these problems forced scientists to stop at a depth of 5.6 miles. In 1977, a company in Austria started drilling a well at a site with plentiful resources, or so they thought. They did find large gas reserves, but there was an unexpected problem. As the drill entered the chamber, the well collapsed. They tried again and made a new, even bigger borehole that went as deep as 5.3 miles. But ironically, they weren't able to drill into the gas chamber again. In Sweden, expectations from drilling weren't met either. At the site of a huge crater 30 miles in diameter, they started the search for gas and oil. It's the largest crater in Europe, which must have appeared because of a meteorite. The well went deep, but unfortunately, nothing of interest was found. At 4 miles down, the drilling stopped. One of the deepest oil wells in the world is Bertha Rogers in Oklahoma. Its depth is almost 6 miles. In 1974, the Lone Star Company achieved such a stunning result in just over 500 days. For 5 years, it was the deepest borehole in the world, until the Kola Super Deep was drilled. Bertha Rogers could probably have gone even deeper, but the drill suddenly struck a molten sulfur deposit. It grew solid around the drill string, breaking the rig. If you can't get to the Earth's mantle from the ground, do it from the water. Project Mohole was just about that. It got its name from moho, the threshold between crust and mantle, and, well, a hole. You know, moho. Well, anyway, the project was launched in the 1960s and was overseen by the U.S. National Science Foundation. The crust on the ocean floor is thinner than on land, and the mantle is closer. Scientists had hoped that a 3-mile deep underwater borehole would bring them there. They chose a location in the Pacific Ocean, where the bottom was at a depth of about 2 miles. There were 2 phases planned for the project, and the first was a success. A total of 5 wells were drilled, each not exceeding 600 feet in depth. Unfortunately, the second phase never happened. Too many problems were involved. So, apparently, there ain't no moho, holes. Today, underwater wells are commonplace. Their main purpose is extraction of oil and gas. The EVA 4000 American drilling platform is located in the Gulf of Mexico. This huge structure rises above the water at a height of a 20-story building. The platform moves around looking for oil at depths of over 6,000 feet, and when it finds a good spot, it's capable of drilling up to 6 miles into the seabed. Now, let's move to Africa. Here at the very south of the continent, there's a huge quarry, the Kimberley Diamond Mine. Now, it's easy to drill through the ground when you have the best equipment, but this hole was literally dug by hand. About 50,000 workers dug it tirelessly in the late 19th and early 20th centuries using ordinary shovels. And no, they hardly wanted to get to the opposite side of the earth. They were attracted by the enchanting brilliance of diamonds. One of the most famous precious stones, Tiffany, weighing 128.5 carats, was found in the Kimberley mine. The depth of the hole reached 790 feet. Just imagine how difficult it was to return from work. It was like climbing 66 floors on foot. When the work stopped, the bottom of the pit was partially filled with soil, and then water flooded the place. Today, it's a popular sight among tourists, and surely, each of them secretly hopes to find a diamond there. With the industrial boom, oil became even more popular than diamonds, and the oil wells around the world are getting deeper. For example, in 2008, Qatar drilled the longest oil well at that time, El Shahid. It was 7.6 miles long, and it only took them a little over a month. The vertical part of the shaft reaches 6.7 miles. Stretched up instead of down, the shaft would reach the height of commercial airplane flights. The record was broken in 2012 by the Z44 Shavo oil well. When they measured its length, the new hole beat the one in Qatar by about 300 feet. Just for a clearer picture, either of these two oil wells would fit almost 15 Burj Khalifas or 40 Eiffel Towers. Moving on to Canada and high up into the sky to look at it from space. See those two huge holes? If you don't know, those are diamond mining sites. You might think that an alien invasion happened while you slept right through. This enormous place is on the island of Lac de Gras, not far from the Arctic Circle. This is a whole city with industrial and administrative buildings, a boiler house, living quarters for workers, and even an airstrip. In 2018, the largest diamond in North America was found here. It weighed 552 carats. Apart from diamonds and oil, the bowels of the earth have a lot of other useful stuff. One example is copper. Let's go to Utah and see the giant Bingham Canyon mine. Copper has been mined here for over a century. The width of this quarry reaches 2.5 miles, and it goes half a mile down. Just imagine how breathtaking a paragliding flight would be over this powerful structure. But the greatest treasure of the planet is, of course, fresh water. And to get to it, people would dig as deep as they have to. The deepest water well in the world is found in Great Britain. It was dug by hand in the 19th century. People just had to keep on digging because they couldn't get to water, and as a result, they reached almost 1,300 feet. When the water finally gushed from under the ground, the workers barely managed to escape from the well. Many of us spend a huge part of our life under the ground. Yeah, I mean the subway. The deepest underground station in the world is in Kyiv, Ukraine. It takes over 5 minutes for the escalator to lower you to the platform. After all, you're traveling nearly 350 feet down. Sometimes nature decides to dig something deep on its own. Most likely, the Mariana Trench is the deepest point in the ocean. Its bottom, called the Challenger Deep, is 6.8 miles below sea level. Sunlight never gets there. The pressure down below is more than 1,000 times higher than on the surface. If you decide to dive to the bottom, you'll spend 4 hours of your time and a whole lot of money on the necessary equipment. Scientists have even found mountains there. By the way, if Everest was moved to the bottom of the Mariana Trench, we wouldn't be able to see its top on the surface. A little riddle: can you dig water? The answer is yes, if it's in the form of ice. The Uran Observatory in Antarctica made it by digging boreholes up to 1.5 miles deep using hot water. Optical detector filaments pass through them. They capture elementary particles, neurons. In fact, this is a telescope that's directed not upwards, but downwards into the ice. But that's a completely different story.
Do you remember when you were a kid and dug deep holes in the wet sand at the beach? You kept digging and digging, wondering where you'd end up if you never stopped. Well, wonder no more. This video has got you covered. Let's explore how far down you may go and what you can find there. And by the way, who knows, maybe someone's already used some fancy schmancy tech to dig all the way down to the planet's core, and we're just clueless about it. Let's dig in. At a depth of 2.3 feet, you'll find a whole lot of tunnels made by moles and rabbits. And get this, those moles are insane at digging. They can make a tunnel longer than 65 feet in just one day. If you dig a bit more, around 6 feet, you'll hit the standard burial depth, in Western culture, that is. Interestingly, the phrase 6 feet under didn't just appear out of nowhere. It was actually a rule implemented by the Mayor of London during the plague outbreak in 1665 to prevent the spread of infection. If you want to see something really gross, look out for deep-burrowing earthworms at a depth of 10 feet. Some species, like Drawita grandis, can grow up to a whopping 3.5 feet long. Yuck! Did you know that a metal detector can only reach a maximum range of 20 feet? If you're trying to find something buried deeper than that, you're out of luck, unless you've got a high-end detector that might be able to pick up a car at that depth. But if you're looking for something small or using a lower-end detector, forget about it. There was a guy named William Little, aka the Mole Man, who lived in London and dug himself a burrow 26 feet deep under his own house. He started way back in the 60s, and it took him over 40 years to dig the whole thing. And get this, the network of tunnels he made stretches over 65 feet away from the house. That's some serious digging. But if you want to see some real animal digging skills, go down almost 40 feet and you'll find the deepest burrow ever made by an animal. You would never guess who dug it. Ready? Nile crocodiles, that's who. If you ever find yourself 60 feet underground, take a look at Beijing's underground city. It's an emergency shelter that's basically a huge network of tunnels and rooms underneath China's capital city. How cool is that? Go down further to about 110 feet below ground in London. You'll find an underground farm where people grow veggies and herbs. Now, let's dive deeper. Literally, the Y40 diving pool in Italy is the deepest swimming pool in the world, and it goes 131 feet down. It's so deep that a free fall into its pit without water takes around 3 seconds. This is actually quite a lot, even if it doesn't sound like that. At about 280 feet underground in Cappadocia, Turkey, you'll find the Derinkuyu underground city, a vast ancient underground complex that presumably dates back to the 7th century. The channel tunnel that connects the UK with France is 377 feet deep. The roots of a wild fig tree growing at the Echo Caves in South Africa go down to 400 feet. And these are the deepest roots we know about. How about spending the night in the deepest hotel room in the world? It's located 508 feet underground at Sala Silver Mine in Sweden. If you're an adventurous runner, you might be interested to know that the deepest half marathon was held in 2004 in the Bochnia salt mine in Poland, at a depth of 695 feet. Are you a fan of engineering feats? The Seikon Tunnel in Japan is the deepest railway tunnel in the world, at a depth of 787 feet. And if you want to drive deep under the sea, you can do so in the Eiksund Tunnel in Norway, which reaches a depth of 942 feet. The deepest hand-dug water well in the world is at a depth of 1,286 feet. It's called Woodingdean Water Well, and it's located near Brighton in the UK. The well was dug in 1862, and most probably it's also the deepest hole dug without any technological aid. Kudos to everyone involved. If you're an adventurer, you might be interested in the deepest natural shaft in the world, which goes down to a depth of 2,110 feet. It's located in the Vrtoglavica cave in Slovenia. And a free fall down this shaft would last for a heart-stopping 11 seconds. In 2010, 33 Chilean miners were trapped at an even deeper depth of 2,297 feet in the San Jose copper and gold mine. They were stuck there for 69 days until they were finally rescued. Moving on, the deepest bat colony in the world resides at a depth of 3,800 feet in a zinc mine in New York. About 1,000 brown bats spend every winter there. Now, the deepest concert in history. The Finnish band Agonizer performed at a depth of 4,166 feet in a mine in Finland in 2007. Imagine rocking out in a venue that deep underground. The deepest coal mine is the Jindřich II mine in the Czech Republic. It was shut down in 1991, but it used to go all the way down to 4,920 feet. Now let's talk about the Grand Canyon. You might not think too much about it, but it's actually super deep. The deepest part of the canyon is about 5,920 feet down, and on average it's about 5,282 feet deep. If you're feeling adventurous, you might want to check out the Krubera Cave in Georgia. It goes down a whopping 7,185 feet, making it the deepest cave in the world. The deepest radio broadcast ever happened in Creighton Mine, Ontario, Canada, which is 7,677 feet below the Earth's surface, and it was held by CBC in 2005. And if you want to get even deeper, there's the Jinping Underground Laboratory in China, which is 8,202 feet underground and the deepest lab in the world. The Moab Khotsong gold mine in South Africa has the deepest single-shaft elevator in the world. It's located at a depth of 10,203 feet, and if you decide to take it, it'll take you 4.5 minutes to reach the bottom. Free fall into its shaft would take as much as 25 seconds. Deep in the Tautona mine in South Africa, at a depth of 11,811 feet, the deepest known multicellular organism has been found. Guess what it is? Obviously, a worm. Oh. Let's remain in the Tautona mine for another moment. Here you can reach the deepest human destination in the world. The temperature down there is a scorching 151 degree F, and the journey takes more than an hour. The oceanic crust has an average depth of almost 20,000 feet, which is also the depth at which the deepest known microbes were found in rocks below China's Songliao Basin. At a depth of about 36,000 feet, we find the Mariana Trench, the deepest point of the ocean. But people have gone even deeper than that. The Kola Super Deep Borehole was until recently the champion of the depths. It's the second deepest artificial hole on this planet, with a depth of 40,355 feet. The scientists once attempted to drill through Earth's crust in a massive project. However, they only managed to drill a third of the way before the drill couldn't operate anymore, due to the temperature reaching 356 degree F. This hole is not easily recognizable as its diameter is just 9 inches, and it looks unremarkable. Nevertheless, it is well covered to ensure people don't accidentally fall into it. If you were to drop a coin into the hole, it would take 50 seconds to hit the bottom. If you are wondering which artificial hole on Earth is the deepest, it's the Z44 Chavo oil and gas well. The depth of this hole is a staggering 40,604 feet, equivalent to the height of 15 Burj Khalifas stacked on top of each other. What's the deepest underground you would dare to go? Share your craziest ideas in the comments below. Did you used to make sandcastles at the beach when you were little? The structure had a moat, so you needed to dig deep. While holding a plastic shovel, you probably thought, how deep can I go? Well, this question motivated a group of scientists in the Far East. They have decided to dig the deepest hole in their home country, China. The drilling team's goal is to reach a depth of nearly 33,000 feet. That's about 1 1/10 times as deep as Mount Everest is tall. The location of the borehole is at the edge of the second largest shifting sand desert in the world, Taklamakan Desert. During a single day, air temperatures there can vary over 100 degrees. The drilling rig is impressive on its own. It weighs some 550 tons and is the height of a 20-story building. And it's pretty powerful, too. It can lift the equivalent of 120 adult elephants. These engineers aren't kidding. One of them compared the project to driving a big truck on 2 thin steel cables. That's why they expect the dig to last well over a year. Their ultimate goal is to drill downward through 10 layers of strata. These are horizontal layers of sedimentary rock. Sounds complicated? Just look at any exposed cliff and you'll notice how it has stripes of different colors. These are the strata I'm talking about. If we translate it from Latin to plain English, we'll get things that spread out. Makes sense. Each layer of rock represents a specific geological period. Remember Spielberg's 1993 blockbuster Jurassic Park? That's just one of these geological periods. It ended some 145 million years ago. But in Central Asia, scientists won't travel that far through time. They hope to reach the rock dating back to the Cretaceous. That's the geological period just after the Jurassic. It lasted until some 66 million years ago. This was the time when T-Rex still roamed North America. But why mount such a complicated operation in the first place? A single goal would be a waste of funds. That's why engineers in Central Asia have several objectives. They want to explore the planet's internal structure. This involves the search for natural resources, such as mineral deposits and oil. Another goal is to collect scientific data on earthquakes and volcanic eruptions. The information will help researchers better predict these events in the future. So, hardcore science is behind this pioneering project, but it's not the first of its kind. Deep in the Arctic Circle lies the Kola Peninsula. And no, it doesn't have anything to do with the famous beverage company from Atlanta. This Kola is a region of great natural beauty, covered in forests and lakes, and an abandoned scientific research station. Inside this crumbling building, a rusty metal cap sticks out from the concrete. It doesn't look that impressive today, but this is the site of the deepest man-made hole on the planet. It is over 40,000 feet deep. That's deeper than the Mariana Trench, 36,201 feet, the deepest place on Earth. Scientists were drilling it for nearly a quarter of a century. The project started in 1970 and finally shut down in 1995. But if you travel to this region close to Norway, you wouldn't be impressed by the shaft. It is only 9 inches in diameter. It would be impossible to fall down such a narrow opening. And despite the figures, the hole is pretty shallow on a bigger scale. You see, the drill bit went through only a third of the Earth's crust. Let me explain. Remember those layers of strata? Yup, that's what our planet looks like on the inside. The 3 layers are the crust, the mantle, and the core. The crust accounts for only 1% of Earth's mass, and it's some 25 miles thick. But it holds nearly all life in the known universe. The deeper you go, the hotter it gets. At the place where the crust meets the mantle, Moho, temperatures max out at 752 degrees Fahrenheit. Ouch. There are 2 types of Earth's outermost shell, oceanic and continental. The crust is thinner under the ocean floor, so why not drill here? Well, the thinnest part is usually the deepest part of the ocean. That doesn't mean that people haven't tried to drill into the seabed. Americans attempted this off the coast of Mexico in 1961, Project Mojole. Drilling underwater was more expensive than anyone anticipated. A few meters of basalt, the researchers were able to bring up costs some $40 million in today's money. Not worth the effort, literally. The Kola Superdeep borehole also burned money quickly. And that wasn't the only heat scientists had to face. The temperature at the top depth was a staggering 356 degrees Fahrenheit. That was double what the drilling team expected. Their machinery simply couldn't operate in that heat. At this depth, rocks behaved more like plastic than rock. If they had gone deeper, the stones would have the consistency of oversized caramels. But the drilling team gave their best. They even invented a new type of drill where only the tip rotated. There was also a lubricant to smoothen the process. This simply means they pumped a lot of pressured mud into the hole. Yet, they came short. Have scientists completely given up? Not by a long shot. The Japanese built a ship, Chikyu, 20 years ago to drill through the seabed, and they have invested a hefty sum in the project, $1 billion. The mission's goal was to drill into the Earth's crust where it's the thinnest. Under the ocean floor, it is less than 4 miles thick. If the Japanese team of scientists succeeds, it will be the first time humans recovered in situ mantle rocks. What is that? In situ is a Latin term that simply means in the original place. The only time we get to see what Earth's mantle looks like is during a volcanic eruption. A plume of hot mantle rising to the surface will form a volcano. You know the rest. But where are the Japanese researchers planning to drill? After all, they have a huge ship, so it could be anywhere in Earth's oceans. They've narrowed it down to 3 locations: Costa Rica, Hawaii, or Baja. In cartoons, Characters often dig up a hole and end up in another country. The idea is that since our blue planet is round and you dig straight down, you'll end up on the other side of the world. Sounds interesting, but this theory has no grounding in truth, pun intended. Science knows more about outer space than about what's underneath our feet. And digging won't get us far. The temperature at our planet's inner core exceeds 10,000 degrees Fahrenheit. The best heat-resistant materials humankind has developed, tantalum carbide and hafnium carbide, can withstand around 7,000 degrees Fahrenheit. Good enough for building spacecraft, but not good enough for traveling to the center of our planet. But will Jules Verne's famous novel, Journey to the Center of the Earth, ever become a reality? For now, we can only imagine. The vessel that would take someone to the center of the Earth would first have to have great insulation. Then it would have to withstand a pressure 4,000 times stronger than at sea level. Let's talk about the finances. The cost of this imaginary mission would be astronomical. The good news is that you could pay it off with what you find underground. At a certain depth, 93 miles, you'll stumble upon diamonds. They form when all that heat and pressure alter the structure of carbon atoms. The final leg of the journey would take you through the Earth's core. The temperature here is the same as on the surface of the sun. And you'd be traveling through molten iron and nickel. But that's not the weirdest fact. The outer core has low gravity. The mass of our planet would be behind you. So the gravitational force would actually pull your vessel backward. Future travelers to the center of the Earth better have a supercharge button. That would be the only way to reach the planet's inner core.
In the world's deepest gold mines, people work at a depth of over 13,000 feet. The deepest oil well on the planet is the Z44 Chavo oil and gas well. Located in the Russian Far East, it goes more than 40,000 feet down. That's 15 Burj Khalifa towers put on top of each other. One of the world's deepest and most famous artificial holes is the Kola Super Deep Borehole. Its depth is also over 40,000 feet. If you dropped a coin down the shaft, it would be falling for 50 seconds before it reached the bottom. A mere 9 inches across, this well was created for scientific purposes. People wanted to drill through the Earth's crust and see what lay below. They managed to pass only 1/3 of the way. After that, the temperature reached 356 degrees Fahrenheit, and the drill couldn't operate any longer. But what if, by some miracle, you managed to drill a hole all the way through Earth? You've got through 8,000 miles of molten magma and solid rock. You've withstood the temperatures of almost 11,000 degrees Fahrenheit and extreme pressure, more than 300 million times more than at the surface of the planet. The well is wide enough for an adult to pass without having to squeeze through. It's also perfectly straight. The hole's walls are incredibly strong and won't collapse or melt. And then, while standing on the well's edge, admiring your handiwork, you slip and fall into the gaping abyss. Considering gravity, acceleration, and the Earth's diameter, it would take you just 42 minutes to fall through the entire planet. You'd reach the maximum speed of 18,000 miles per hour at the Earth's center. And in less than an hour, you'd emerge on the other side of the planet. Unfortunately, in the real world, you might not even get through the first mile of your fall. The Coriolis effect is to blame. Our planet's surface moves at a speed of 1,000 miles per hour at the equator, but Earth's insides don't need to move that fast. Picture a racetrack. Traveling along its inner part, you'll drive a shorter distance than when moving along the outer side. It means that soon after falling into the hole, your speed will become greater than that of the hole around you. After traveling for 1 mile, you'll crash into the side of the well and begin to careen and bounce off its sides. If you were halfway to the center of the Earth at that point, your speed would be 1,500 miles per hour faster than the walls of the hole. But let's say you know about this effect and manage to avoid it by digging a hole directly through the Earth's poles. Only in this case will the gravity pull you straight down. On your way to the Earth's center, you'll see tons of cool stuff. First, you funnel past countless rabbit warrens and mole tunnels. By the way, a mole can dig a 60-foot-long tunnel in a day. When you're about 10 feet down, you have a near crash with a giant earthworm. If the creature was standing, it would reach your waist. At a depth of 26 feet, you dash past the tunnels dug under the Mole Man's home. William Little, a British civil engineer, spent about 40 years to create an enormous web of caverns and burrows stretching far beyond his house. Almost twice deeper, and you're speeding by a Nile crocodile. This reptile digs the deepest burrows among all animals. You hardly have enough time to recover from this shock when you fly by is it an underground farm? Indeed, you spot vegetables and herbs growing there. You zip through the bottom of the deepest swimming pool in the world. It's the Y40 diving pool in Montegrotto Terme, Italy. It goes 131 feet down. For some reason, it's not filled with water at the moment, and you need a mere 3 seconds to reach its bottom. When you're more than 500 feet underground, you spot people lounging in a hotel room. It's Sala Silver Mine, the world's deepest hotel, built in a converted silver mine. At a depth of 3,300 feet, you start to experience immense pressure. It feels as if 4 elephants were piled up on your head. After that, you can continue your journey only if you're wearing a suit that can protect you from the ever-increasing heat and air pressure. You move deeper and see the Homestake gold mine, almost 5,000 feet below the surface. Before closing, it was the deepest and largest gold mine in North America. In the 1960s, scientists detected and counted tiny subatomic particles from the sun. They did it in a lab located inside the mine. After falling for another second or so, you reach permafrost. It's a thick, permanently frozen layer of soil that doesn't warm up even in the summer. It mainly occurs in polar regions and is the thickest in northern Siberia. Now you're more than 6,000 feet below the surface, and you still come across some living creatures. Those are springtails, teeny eyeless insects that live in the Krubera Cave in Georgia. But the deepest multicellular animal you meet lives at a depth of 11,800 feet in the Tautona mine in South Africa. Tiny, but incredibly hardy, this worm can deal with extreme temperatures and dehydration. 4 miles down, and you dash through the oceanic crust. It's the part of the Earth's crust that lies under the ocean and is much thinner than the continental crust. Twice deeper than that, and the tunnel leads you through a pool of scorching hot molten rock. That's Yellowstone supervolcano's magma chamber, below Yellowstone National Park. It means you're about to leave Earth's outermost layer, the crust, behind. The deeper you go, the hotter it gets. At the boundary with the mantle, about 18 miles below the surface, the temperature reaches 750 degrees Fahrenheit. Now you're moving through Earth's upper mantle. The pressure there reaches 10,000 atmospheres, like more than 130 elephants standing on your head. But it's nothing compared with the lower mantle pressure, 240,000 atmospheres. The temperatures keep rising as well. Near the boundary with the planet's core, it's already more than 7,000 degrees Fahrenheit. The outer core is 1,500 miles thick and is made mostly of iron and nickel in their liquid form. There, Earth's magnetic field is 50 times more powerful than at the surface. You are more than 3,000 miles down underground when you reach Earth's inner core. It's incredibly dense and spins faster than the rest of the planet. It's almost as hot as the surface of the sun, 9,800 degrees Fahrenheit. The pressure inside the inner core is 3 million times greater than on the surface. And still, you somehow make it through this solid ball of metal and back to the surface. In real life, though, you'd be crushed by immense pressure and burned by incredible temperatures soon after the beginning of your fall. No suit would be able to protect you from such extreme conditions. Even if neither pressure nor scorching heat influenced you, you'd still have several serious problems on your hands, and all of them would be connected with air. For one thing, it would be air resistance. It would pull you to a stop long before you reach the core. But a much worse issue would be air pressure. The deeper you'd get down the hole, the more air would be above your head, and the higher its pressure would be. At a depth of 30 miles, it would be as great as that at the ocean bottom. After several hundred miles, the air would turn into an almost solid plug, blocking your way. But let's say you knew about this problem in advance and pulled all the air out of the well before plunging in. And now, you're moving in a vacuum, dressed in a special suit with a large oxygen supply. Still, you're going to come across something bizarre on your way. During your fall, you'll notice that the force pulling you downward starts to weaken, and once you reach the center of the planet, it'll disappear whatsoever. Earth is an almost perfect sphere. That's why the gravitational forces coming from the mass surrounding the planet's center counteract one another. Feeling equal pulls from all sides, you'll become weightless. Paradoxically, you'll be floating in the air and moving at breakneck speed at the same time. Soon, you'll travel through Earth's inner core and keep going until you get to the other side. In any case, this situation is entirely hypothetical. The very idea of building an 8,000-mile-long tunnel sounds implausible. You'd need to find where to store all the material pulled out of the hole, including Earth's molten insides. You'd also have to ensure your tunnel wouldn't collapse while going through the planet's liquid layers. Its walls would have to be made of a material that could withstand the heat of more than 10,000 degrees Fahrenheit. So far, no substance on Earth can remain intact at such temperatures.
It was early morning on the 30th of June, 1908, when a terrifying explosion occurred in the sky above the stony Tunguska River in Siberia. It left 80 million trees flattened, and the affected territory was more than 820 square miles. Thousands of people within 900 miles experienced the Tunguska event, and later, researchers managed to collect more than 700 accounts. Most reports mentioned a fireball in the sky. It was glowing like a second sun. People also spoke about a series of explosions that produced frightful sounds. Sometime later, the ground started shaking as, according to some witnesses, the earth opened wide and everything started falling into the abyss. Was that what really happened? Scientists aren't 100% sure. The indigenous Yakuts in Evenks, for example, believe that a deity sent the fireball to get rid of our world for good. At the same time, numerous meteorological stations in Europe recorded both atmospheric and seismic waves. Days later, weird phenomena were observed in the sky over vast territories, reaching Europe. Those were glowing clouds, colorful sunsets, and even a weak luminescence at night. Some reports mention a blue tube in the sky. International newspapers were speculating about a powerful volcanic eruption. Some scientists thought it could have been a cosmic impact. Unfortunately, it was hard to access the region where the event had occurred, which prevented further scientific investigation. In 1921, mineralogist Leonid Kulik got interested in this story after reading a newspaper article that claimed that passengers of the Trans-Siberian Railway had seen the impact. There were even claims that some of them had managed to touch the still-hot meteorite. Kulik organized an expedition and traveled to the city of Kansk. There, he studied the reports about the event, everything he could find in the local archives. It turned out that the story about the train passengers seeing and encountering the meteorite was a hoax. But Kulik and his team didn't give up. They traveled to the region, following first the Angara River and then the Tunguska River. Then, on April 13, 1927, the researchers discovered a huge area littered with rotting logs. Some extremely powerful force must have flattened them. Shockingly, only at the epicenter of the blast, in the forest of Tunguska, some charred trees were still standing. But the most baffling thing was that even after exploring the entire area, the team didn't find an impact crater or any meteor material. So, in the fall of 1927, Kulik's report was published in different national and international papers. The scientists suggested that an iron meteorite could have exploded in the atmosphere, causing the observed powerful explosion and following devastation. He explained the lack of an identifiable impact site by the swampy ground. The soil could have been too soft for the impact crater to remain. So, despite the lack of physical evidence, Kulik called the event Filimonovo meteorite. Filimonovo was the railway station where people saw an ultra-bright light in the sky. Only sometime later did the incident get its name, Tunguska event. Even though this event is quite popular all over the world, scientific data describing it is sparse. Since 1928, more than 40 expeditions have explored the site. They took samples from the soil, rocks, trees, but the results were always ambiguous. Some seismic and air pressure wave registrations, which were recorded right after the blast, are still intact. Plus, about 30 years after the event, researchers mapped the area of the destroyed forest. But since there's almost no hard data, like a crater or a meteorite, and the accounts of the incident are conflicting, many theories of widely varying plausibility have appeared over the years. Among them, there was an asteroid skimming the atmosphere of our planet, and a primordial black hole passing directly through it. Wait, what? At the current age of the universe, black holes form when huge stars run out of fuel and collapse under their own gravity. In other words, there's a limit to how small a black hole can be in the current universe. It has to form from substantial amounts of mass gathered in one small region of space. Plus, it can only occur to stars around 20 times the mass of our Sun and larger. But primordial black holes are something else altogether. Their existence hasn't been proven yet, so they remain purely hypothetical. Primordial black holes could have formed in the first few seconds of the existence of the universe. At that stage of its development, all the stuff that would later continue to create stars and galaxies were packed together much more tightly. At that time, pockets of hot material might have been dense enough to form various black holes, from giant to teeny tiny ones. The masses of such holes could have been 100,000 times smaller than that of a paperclip. At the same time, these holes could have reached a mass of 100,000 solar masses. Soon after, the universe started to expand very quickly, and it also cooled down. This put an end to the conditions favorable for the formation of primordial black holes. Unfortunately, we haven't detected any such holes yet. But if they formed right after the birth of the universe, it's possible that they might still be somewhere out there. And there's an idea that primordial black holes, smaller than an atom, might be passing through Earth every day without harming our home planet. A larger primordial hole might also visit us every once in a while, every 1,000 years or so. After learning more about the Tunguska event, a team of physicists published an article in a 1973 Nature paper that the event itself could have been caused by a primordial black hole passing through the planet. The researchers stated that a black hole with the mass of a large asteroid could explain the lack of a crater or any other physical evidence of the impact. Blue light noticed by witnesses seemed to fit this theory too. According to the team, in such a case, most of the radiation from the shock front would be in the ultraviolet vacuum. It would then get absorbed and re-radiated at longer wavelengths. There would be just a bit of hard X radiation, and the accompanying plasma column would look deep blue. Admittedly, it's a very unusual theory. But the team also suggested a way their idea could be tested by looking for signs of an exit wound on the other side of the planet. You see, if a black hole entered Earth, the rigidity of the rock wouldn't allow for any underground shockwave. Because of the black hole's high velocity, and because it would only lose a tiny fraction of its energy while passing through our planet, it would follow almost a straight line through the planet. Such a potential exit could provide a check for the entire hypothesis. The team also suggested looking for shock waves and disturbances in the ocean on the opposite side of the world. But there's a problem with the idea of a black hole passing through Earth. Such a black hole could settle into the core of our planet, and its gravity would allow the black hole to start feeding, eventually devouring our entire world. Plus, there would be a lot of heating. You see, during its passage through Earth, the black hole would gather a lot of matter, and this process would produce a lot of heat. To put it simply, the impact of an asteroid-mass black hole would release almost the same amount of energy as the impact of an asteroid, like the one that destroyed dinosaurs. Luckily, according to the existing calculations, the chances of a black hole settling in the core of our planet are minimal, since black holes are just too fast to do so. In any case, the Tunguska event being a black hole passing through our planet is certainly an exciting idea, but no evidence that could prove it has been found yet. Plus, we still don't know whether primordial black holes exist at all. Yep, it's something to ponder.
Lake Michigan is one of the largest and most mysterious freshwater lakes in the United States. And now, deep inside it, scientists have stumbled upon something unexplainable. Vast, round craters scattered all across the lake's floor. It all started in 2022. A team of researchers wanted to map the lake's bottom and look for some shipwrecks. At first, they were sure it's going to be just some typical rocky terrain or sandy patches. But what they saw on their sonar screens stopped them cold. Strange, circular shapes that looked almost too perfect to be natural. They were hiding about 500 feet beneath the surface, in places where the water turns dark and impenetrable. Those guys are huge, ranging from 300 to 600 feet wide. They also plunge nearly 40 feet deep. And there are dozens of them, neatly arranged like some footprints. But the team had no idea what these things were. Then, in August 2024, the mystery only deepened. Using a remotely operated vehicle, they got a closer look at these formations. There were about 40 of them. No one had ever seen anything quite like this before in the Great Lakes. What could have created those craters? Could they be ancient? Perhaps remnants of some geological event lost to time? If that's the case, it's weird how long these holes have likely been sitting there, undisturbed. Theories started popping up. One possibility was that they could be sinkholes or dolines. Those are basically holes that suddenly appear in the ground when the surface layer collapses. The rock beneath the surface, often made of limestone, gets slowly dissolved by water over time, creating voids underground. When the surface of those voids can no longer hold its own weight, it caves in, and this forms a hole. Think of it like when you poke a straw through the lid of a drink. Sinkholes can be small dips or huge, spanning up to 2,000 feet. They can happen gradually or all at once. Sometimes they can swallow entire cars or even buildings. And Lake Michigan sits on limestone bedrock. It erodes pretty easily when water flows through it. Sinkholes like these have already been found in Lake Huron, and they look kinda similar. But there are some plot holes, no pun intended, with this theory. For example, it's wild how they all would be so huge. It's also weird and pretty rare for sinkholes to occur in a lake bed. They also kinda resemble a straight pattern. They seem to extend generally southward, forming a loose line, which is pretty weird. If these are sinkholes, then they're definitely not playing the usual geological rules. Though it might be some new, unusual process at play beneath the lake's surface that we haven't discovered yet. There's another theory though. Glaciers. Glaciers are wild rivers of ice. They covered much of the Earth during the last ice age, and they're incredibly powerful. While they might move slowly, sometimes only a few inches per day, they have such immense weight that they can reshape entire landscapes over thousands of years. Glaciers can grind and scoop the land beneath them. They're basically like colossal bulldozers. Their weight, combined with the slow but steady movement, grounds down everything beneath them: rocks, soil, even bedrock. This can create deep gouges in the Earth's surface, called glacial troughs. During the last ice age, there were lots of glaciers all over the northern US, including the Great Lakes region. If they moved across what is now Lake Michigan, they could have carved out these deep holes. Glaciers often move in a pretty straight path. As they move, they cause terrain to erode, but the resulting erosion varies based on terrain. Sometimes there are places where the bedrock is softer or fractured, and these places are more easily carved and crushed by the glacier. That could explain why some holes could be bigger and deeper than others. Harder bedrock is less affected. But usually this leads to rounded, crescent-shaped depressions known as chatter marks. Those marks are more like grooves rather than circular, big craters like those in Lake Michigan. Once the glaciers melted, the Great Lakes themselves formed. If the craters were formed by them, they may have filled with water, becoming part of the Michigan Lake. Though this theory is more like a speculation, so we need more evidence. But there's another layer to this mystery. The craters are not just curious geological formations. They actually may hold valuable clues about early life on Earth. Parts of Lake Michigan, especially dark ones, are relatively low in oxygen. It's like a lighter version of deep ocean environments that often have very little of this element. For example, hydrothermal vents deep in the ocean, underwater openings in the Earth's crust with some hot, mineral-rich water that are often very low in oxygen. But some organisms love places like these. For example, opossum shrimp. Teeny tiny shrimp-like creatures that love cold, deep waters. They get their name because they have a pouch to carry their young until they're ready to be on their own, like an opossum. Or deep-water sculpin fish, small bottom-dwelling fish that also enjoys cold lakes. They're well adapted to living in dark waters and usually stay close to the lake bed. And weird organisms like invasive quagga mussels, which kinda look like shells. These are small freshwater mussels that have spread there to the Great Lakes. They attach themselves to hard surfaces and can cause problems for ecosystems by competing with native species for food and space. All these guys could be in Lake Michigan, and even more. There might be microbes or even bacteria that are specially adapted to these harsh conditions, just like it was in Lake Huron. There's only a handful of creatures that could survive deep within these craters, and studying them could give us insight into how life once flourished in Earth's ancient, oxygen-poor oceans. That's because it's in places similar to these where some of the earliest life forms thrived. Early Earth had an atmosphere with little oxygen, although it was much more hot and ancient microbes adapted to this. The Great Lakes, especially Lake Michigan, have always had a bit of a ghostly reputation. Like even this mission was organized to study the shipwrecks. There were about 6,000 of them in the Great Lakes. Many of these wrecks are still sitting on the lake beds, preserved by the cold, fresh waters. And shipwrecks aren't the only strange things tied to the Great Lakes. Over the years, there have been stories of unexplained disappearances. Boats and even planes have vanished without a trace. The lakes, often calm on the surface, can suddenly turn dangerous with unpredictable storms and massive waves, leading to these mysterious events. Not even mentioning all the creepy stuff people noticed there over the centuries, such as ghostly lights above water or bizarre weather patterns like eerie, sudden fogs that seem to appear out of nowhere. In 2007, they even discovered some prehistoric structure that looks like Stonehenge there. Well, it was way smaller, but still. It lay about 40 feet below the surface in the heart of Grand Traverse Bay, and it's speculated to be about 9,000 years old, way older than Stonehenge. Looks like this is a print of those who lived in the area thousands of years ago. These massive stones are arranged in a careful, winding pattern stretching over a mile. They range in size from basketballs to compact cars. But one, in particular, stands out. A boulder 3.5 to 4 feet tall, 5 feet wide. It's etched with the image of a mastodon, a creature that roamed the Earth about 11,000 years ago before it went extinct. It probably sank there during the end of the last ice age we mentioned. This period had reshaped the region. This place is underwater now, but back in the day, it was still dry land. So the stones were probably created by people who lived there, though we're not sure why. Were they used as hunting blinds? Or was it some sort of an ancient calendar? Who knows? Only about 15% of the Great Lakes floors have been explored. Now, scientists are gearing up for a deeper dive into this mystery, both literally and figuratively. They want to analyze the lake beds surrounding the craters, hoping that maybe something in the environment around them might have caused them to appear. They have initiatives like Lakebed 2030. These missions should map the entire underwater landscape. This would help us learn tons of interesting stuff about Lake Michigan and our planet's past. Who knows what other secrets these dark waters hide?
Well, we've been miscalling Uranus all this time. Actually, astronomers say we should be pronouncing it like Uranus, not Uranus. I can't say a different stress changes much, though. However, things could have been different. Initially, Uranus was supposed to have the majestic king-like name of George, because astronomers wanted to name it after King George III. In the end, they changed their minds, and now, well, it's the punchline of every joke. If you take the total cost of launching a mission and divide it by the weight of the cargo, you'll see some pretty mind-blowing figures. According to specialists, back in 2016, it used to cost $10,000 to send just 1 pound of cargo into space. But now, prices have gone through the roof. Cygnus spacecraft's cargo costs over $43,000 per pound, while SpaceX's new carriers come in at around $27,000 per pound. Remember how hard it is to pay $5 for water at airports? Now, a bottle of water in space would cost somewhere between $9,000 and $43,000, and that's only to have it delivered in space. Now, as for water in space, well, it used to be considered a super rare thing. But in reality, there's water ice all over our solar system, so you don't have to buy those overpriced $43K water bottles. It's hanging out there in comets, asteroids, and even in hard-to-see craters on Mercury and the Moon. We're not sure if there's enough water in these places to support colonies of people, though. Mars also has ice at its poles, hiding under the surface dust and frost. Even smaller celestial bodies, like Saturn's moon Enceladus and dwarf planet Ceres, have ice. NASA scientists think there might be a chance of finding life on Jupiter's moon Europa. There might be liquid water beneath its icy shell. Europa, even though it's a lot smaller than Earth, might have an ocean deep enough to hold twice as much water as all the oceans on our planet combined. In 2009, scientists exploring a massive cloud of dust and gas in the center of our galaxy stumbled upon a fascinating surprise. They found ethyl formate within the cloud. This chemical is responsible for the delightful flavor of raspberries and has a rum-like scent. Furthermore, another nearby region is brimming with ethyl alcohol, the same type found in many beverages. In fact, there is enough alcohol in this region to provide every person on Earth with 300,000 pints of beer every day for the next billion years. Now, believe it or not, we do have a black hole on Earth. The thing is, creating an in-lab black hole was a sort of indispensable thing to do. Studying black holes in real space remains a distant dream, so it was only possible to create one to experiment with in a lab. A group of scientists in the Netherlands wanted to explore the mysterious Hawking radiation theory proposed by the iconic Stephen Hawking. Using atoms to mimic an event horizon, they orchestrated electrons, causing a surge in temperature that resembled flat spacetime. As particles moved through quantum fluctuations, a ring of infrared radiation appeared around the lab-grown black hole, mirroring Hawking's idea. So, if you totally understood what I just said, could you please explain it to me? Now, it may sound insane, but you can totally be allergic to the moon. Long story short, it was the final Apollo mission, and they brought back more rock samples than ever before. Plus, they had the first and only pro-scientist on the moon, Jack Schmitt. He was a geologist, and his rock samples helped scientists learn more about the moon's magnetic field and volcanic history. During the expeditions, it became evident that Jack Schmitt was allergic to moon dust. The gritty, sticky powder clung to his suit and his skin, causing irritation in his sinuses, nose, eyes, and throat for a couple of hours after he took his helmet off. Meanwhile, neutron stars are extremely dense, being basically just a bunch of neutrons squished into a super small space. If you had just a teaspoonful of this stuff, it would weigh more than the entire human population combined. And to match the density of a neutron star, we'd all have to squeeze into the space the size of a sugar cube. No thanks. When it comes to outer space, we tend to think that Earth and the Moon are pretty close together. But in reality, you can actually squeeze all the other planets of our solar system between Earth and the Moon. The average distance between them is about 240,000 miles. If you added up the diameters of the 7 planets, you'd still have some room to spare, about 5,000 miles. In 2011, scientists made a groundbreaking discovery of a massive reservoir of water in space. This water, equivalent to 140 trillion times all the water in Earth's oceans, could provide each person on our planet with a planet's worth of water 20,000 times over. This reservoir was located near a massive black hole drawing in matter and emitting energy, known as a quasar. The water was formed by energy waves colliding hydrogen and oxygen atoms together, and it was found around 12 billion light-years away. So, when the Curiosity Mars rover snapped its very first sunset picture in 2015, scientists were practically doing backflips from excitement. Turns out, sunsets on the red planet are anything but red. They're actually a stunning shade of blue. According to NASA, the reason behind this phenomenon is that the dust in Mars' atmosphere is like a magical filter that lets blue light shine through while blocking out those warm tones like yellow, orange, and red. Well, Venus is a slow spinner compared to Earth. It takes this planet 243 days to make a full rotation, and it spins in the opposite direction. But even though Venus takes longer to spin around, it zooms around the Sun in just 225 days because it's located so close. So, believe it or not, a year on Venus is actually shorter than its day. So, you might think that the night sky should be full of stars with no dark spaces at all. This idea is known as Olbers' paradox, named after German astronomer Heinrich Wilhelm Olbers. He thought that if the universe was infinite, unchanging, and timeless, then we should see stars everywhere we look. But it turns out that the universe is not infinite, unchanging, or timeless. Edwin Hubble discovered that the universe is actually expanding, and the leftover radiation from the Big Bang tells us that the universe is about 13.8 billion years old. Think of all the birthday candles. Ooh! So, the reason we don't see stars in every direction is because some stars are just too far away, or they haven't been around long enough for their light to travel all the way to us. During the Apollo 16 lunar mission, Ken Mattingly, the command module pilot, had a bit of a scare when he realized his wedding ring was missing. The whole crew frantically searched the spacecraft for it, but no luck. Finally, on day 9, while Mattingly was on a spacewalk, the ring was spotted floating out the hatch door. Charles Duke Jr. tried to grab it but missed. Luckily, it bounced off Mattingly's helmet into Duke's hands. It's cool they found the ring, but there are many other things people left up there. There's even a toothbrush floating around somewhere. Mercury is already the tiniest planet in our solar system, not counting Pluto, of course, and the second densest after Earth. And believe it or not, it's actually shrinking and getting denser. For a long time, scientists thought Earth was the only planet with tectonic activity. But that all changed when the Messenger spacecraft flew by Mercury, giving us a detailed scan of the whole planet. In 2016, Messenger discovered these cool cliff-like formations called fault scarps. Since they're still relatively small, scientists think they're pretty new, suggesting that Mercury is still contracting 4.5 billion years after the solar system began. And around 10 years ago, Australian astronaut Luca Parmitano went through a near-drowning experience during his spacewalk due to a water leak that went unaddressed. Nobody knew how it happened and why Luca ended up having water in his helmet. NASA was investigating the issue for months, but they were unable to determine the exact cause of the water entering Luca's helmet. Whittingdean Water Well. It may have the title of the deepest hand-dug well in the world, but at first sight, it's just a small covered well you wouldn't even assume that it's there. It's located somewhere close to Brighton and Hove, England. Despite its inconspicuous appearance, it's as deep as the Empire State Building is tall, 1,280 feet straight down into the dark, wet ground. Hey, toss in a penny and make a wish. Wait, it's not a wishing well. Never mind. In the middle of the 19th century, one powerful corporation wanted to build a new workhouse in the area that today is known as Elm Grove. They decided to add it to an industrial school for juveniles as well. It was established for those whose parents were living in the local workhouse, and the aim was to teach the youth the habits of industry. The corporation wanted to provide water for their new institution, so they dug a new well. It was too expensive to bring piped water in from the nearby waterworks. They first wanted to make a 6 feet wide brick-lined well down to about 400 feet. That's where they expected to find the subterranean water table. They were digging for 2 years, and the shaft went past those depths, but they still didn't find any water. They thought they somehow missed the water source, so they started digging horizontally in 4 different directions. Even after many hours of work and multiple tunnels in different directions, still nothing. For the next 2 years, they didn't stop digging. Workers would descend rickety ladders hundreds of feet below the surface, illuminated just by the light of candles. They only used hand tools to load their buckets with soil and pass them up to the surface. Then they would use bricks other workers would send down from above to line the narrow interior. The heat down there was intense. They were able to breathe thanks to steam engines that would pump air through pipes down below. After 4 years of digging, they got to a depth of 1,285 feet. 850 feet of that was below sea level. At that point, the water finally broke through the surface. But as it was coming up, the workers were trying to escape it. It took them 45 minutes to scramble up such a deep shaft. It was expensive, and the company put enormous effort into this well, and they used it for just 4 years. They abandoned the well in favor of some other, more practical one. A 2-foot flint and brick wall is surrounding Whittingding water well now. There's also a metal lid covering its top so people wouldn't fall in. It would certainly feel like a journey to the center of the earth, don't you think? It took a research team 20 years to drill down the Kola Super Deep borehole. This one is over 40,000 feet deep, and despite getting so deep, they never actually reached the mantle. The drill bit was just around 1/3 of the total way through the crust to the mantle. The heat was insane, which made their work extra hard. Also, their drill got stuck in a rock, so the whole project was finally abandoned in 1989. The Kola Peninsula is located deep in the Arctic Circle. Forests, lakes, snow, and mysterious mists kind of turn this area into a scene from a fairy tale. But in the middle of one crumbling building there, you can see a heavy, rusty metal cap. It's embedded in the concrete floor, as well as secured by a thick, rusty ring of metal bolts. And that's the deepest artificial point on our planet. Bingham Canyon Mine, near Salt Lake City, Utah, is a cool one too. More people know it as the Kennecott Copper Mine. This mine spans 3 square miles and produces more copper than all other mines have in our world's history. It was opened at the beginning of the 20th century. It's owned by a large multinational corporation at the moment. Back in 2010, they even declared they'd like to dig the mine further and deepen it for another 300 feet. Bingham Canyon Mine has so many roads. If you could stretch them out into one large road, it would go from Salt Lake City all the way to Denver. There was a massive landslide in April 2013 in this area, so strong it even caused its own earthquakes. This is the world's deepest open-pit mine, so deep astronauts can see it from orbit. Humans first started digging towards the planet's mantle in the 1960s. That's when American scientists began with something they named Project Mohole. The project got its name after a man who found the boundary between the Earth's mantle and crust. The team didn't drill on land, but on a boat in the ocean. The crust is actually thinner on the ocean floor, although the difficult part is that the crust is the thinnest in areas where the ocean is deepest. Go figure. The researchers were drilling next to the island of Guadalupe, which is off the west coast of Mexico. There's a pit of impressive size and an amazing background story. One man in a drought-ridden part of India has really done the impossible. He dug a well in only 40 days. His wife wasn't allowed to draw water from a well that was in the village because of the caste they belonged to. The man decided to dig a well by himself and give a source of water both to his family and the community. Nobody believed it was possible, but he took his shovel and kept digging day after day before going to work every morning, and later in the evening after he would finish the work. 40 days later, he finally got to the water and proved that some people can sometimes truly stretch their mental and physical limits to achieve what's impossible. Now imagine how difficult it is to dig a mine by hand. And we're talking about a really big hole mine. They would mine diamonds without any machinery. You can find such a case in South Africa in the province of Kimberley. A geological pipe there was formed after a breakthrough of gases in the crust of our planet. The pipe was named Kimberlite after the location, just like others in that area. It's in the shape of a pretty large carrot. You can see its upper conical part that narrows as it goes deeper, turning into a vein in the end. 1870 was the time when the diamond fever began in the city of Kimberley. Nearly 50,000 people were mining and extracting more than 20 million tons of soil using only their picks and shovels. The development area was close to 2 million square feet. They dug up to 787 feet from 1871 to 1914 and extracted enormous amounts of diamonds, worth more than $1 billion. This mine has become an artificial lake. Today, it's the most picturesque landmark in this province. Darvaza Crater is one of the world's most unique spots you can find. It's a burning hole people actually made more than 40 years ago. This gaping crater opened up in the desert of Turkmenistan. It was most likely a consequence of a drilling mishap. Geologists then set it on fire on purpose. They were afraid all those noxious gases would have a negative impact on the environment, so they wanted to burn them off. They also wanted to prevent the spread of methane gas after the ground below the drilling rig collapsed into a cavern. So now we have a 98-foot deep hole. They thought the crater would burn for only a week. Oops, but they were wrong. Thing is, the crater's been burning for over 40 years now. Actually, it's not that bad. The hole on fire eventually turned into a quite popular spot that attracts many tourists. This site looks like the portal to the Earth's core. Hey, maybe you have some marshmallows we can roast? A word of warning, when you're in Australia, never stick your finger into these holes. They might be home to burrowing spiders. Some species have a bite powerful enough to pierce nails. It feels similar to a hammer on your finger because of the venom. So always give your boots and outdoor clothes a quick check to be safe. Animals sometimes make homes or look for food in them, especially bandicoots. Silk-lined burrows in shady spots might belong to funnel web spiders. The silk works as a trip line to alert the spider inside about what's happening outside. Look for shiny dark brown to black spiders with finger-like spinnerets at the end of their abdomen. Then you'll find them. Males have a hefty mating spur sticking out of the middle of their second pair of legs. When these spiders feel threatened, they make aggressive moves, rearing up and showing off their startling fangs. These spiders, which belong to the Aranida order, are known for their funnel-shaped webs that widen at the entrance. They patiently wait in the narrow funnel for prey to touch the web, then swiftly capture it. In Australia, large brown spiders frighten people due to their venomous bites. They are infamous for causing people to lose their lives in southern and eastern Australia, particularly in the Sydney area since the 1920s. Quick access to the antidote after a bite is crucial in preventing severe consequences. The next spider is one of the world's most dangerous venomous spiders. Phonutria nigriviter is a spider living in South America. People often call it the Brazilian wandering spider. You see, in Brazil, 4,000 people get bitten by this critter each year. The bites can cause serious issues, such as hypertension, blurred vision, sweating, and vomiting. You wouldn't want to mate with this creature, as you can also face way more severe consequences than blurred vision. In some situations, its kiss can take a life. Apart from messing with humans, this spider has a diverse menu, including crickets, katydids, and even larger options like tree frogs, lizards, and bats. Operating under the cover of darkness, these creatures are the most active during the night. They ambush their prey instead of relying on webs. In the daytime, they seek refuge beneath logs or in narrow crevices. They love to be around banana trees, but can be found in urban areas and inside homes too. If you spot them one day, be prepared. This creature's body is covered with thick brown hair and is not that small. In 2013, a London family had to leave their home due to an infestation of Brazilian wandering spiders. The trouble began when an egg sac, hidden in a bunch of bananas, made its way to their local grocery store. No one noticed. When the family bought the bananas, the egg sac broke open. Potentially lethal spiders spread around the house. Over 2,500 people visit poison control centers annually in the U.S. Black widows are spiders with the signature hourglass mark on their bellies. Well, let's talk about their bite. These creatures have a bad reputation because their venom is supposedly 15 times stronger than what rattlesnakes pack. When they bite humans, the bite causes muscle aches and nausea. The venom can even mess with breathing by paralyzing the diaphragm. Despite these cases, most people who get bitten don't end up with serious issues unless they're elderly or very young. These sneaky creatures don't pick just one spot to hang out. You can find them in wood piles, burrows, or among plants that act as scaffolding for their webs. Black widows are especially dangerous for other insects and their mates. After a not-so-romantic mating dance, ladies sometimes go all Hannibal Lecter on their mates. These spiders are architects too, spinning massive webs where females stash a cocoon loaded with hundreds of eggs. Baby spiders move out once they hatch, but the web stays put. Those webs are also traps. Different kinds of prey later join the black widow's spooky snack collection. Yellow sac spiders range in size from approximately 0.12 to 0.6 inches and construct silken tubes under stones, in leaves, or in grass. They're found across the United States and southward toward Mexico and South America. They are venomous to humans and, unfortunately, are commonly spotted indoors. The venom of the yellow sac spider contains cytotoxin. This is a substance that can damage or impair cell function. Reactions like redness and swelling at the bite site are common. Yellow sac spiders are not known for their calm nature either. For instance, a female yellow sac spider may bite when protecting her eggs. These spiders usually come in different light colors. They can be a hassle for people in more than one way. Your car can be in danger too. On rare occasions, they may even set up nests in car engines. Moving on to wolf spiders. They're part of a large and widespread group found worldwide. They're named this way for their wolf-like hunting behavior of chasing and pouncing on prey. Around 125 species exist in North America, and approximately 50 live in Europe. These spiders are typically dark brown, with long, broad, hairy bodies and sturdy elongated legs. Like me. Just kidding. They're super speedy. While they usually create silk-lined tubular nests in the ground, some may conceal the entrance with debris. Others build turret-like structures. A few species also spin webs. Wolf spiders may bite in self-defense. They are venomous, but their bites are not considered dangerous. Some people who are allergic to spider bites may experience nausea, dizziness, and an elevated heart rate. The bite of the spider's large fangs is similar to a bee sting, so it can cause a physical wound at the bite site, and the venom may cause itchiness. The combination of their powerful bite, rapid movements, and startling appearance can be quite unsettling. Beware of the redback spider, the close relative of the notorious black widow. It used to live in Australia, yet it has managed to spread its web across New Zealand, Belgium, and Japan through grape exports. The distinctive red stripes or hourglass marks on their black backs are more noticeable in females. Disturb a female, and you'll see how she can defend her eggs. You're likely to get bitten. These spiders can sneak into shoes or clothing, lurking against the victim's skin while they're dressing. Both male and female redbacks have a venomous bite. Their venom is a cocktail of neurotoxins. It can cause sweating, rapid heartbeat, and swollen lymph nodes. The redback has control over the venom dose, so symptoms vary based on how much is injected. Australia deals with over 250 redback bites annually, many requiring anti-venom treatment. The latest case, when a person lost their life after being bitten, dates back to 1956. Yet it can happen, so stay vigilant and cautious around these stealthy spiders. Let's talk about the heavyweight champion of the spider world, the Theraphosis blondie, casually known as the Goliath bird eater. This giant tarantula can stretch up to 11 inches and tip the scales at 6 ounces. To put it in perspective, This spider is big enough to cover your dinner plate and is certified by the Guinness World Records. The nickname might make you picture a tarantula feasting on a hummingbird, but that's more of an artistic exaggeration dating back to the 18th century. These spiders are more into munching on arthropods and rarely go for bird snacks. Goliath bird eaters don't bother with webs like their spider buddies. Instead, they're all about silk, using it to line their cozy burrows beneath the forest floor. The spider itself looks dangerous, but its bite almost never requires a doctor's visit. It feels more like a wasp sting. Goliath bird eaters are the biggest spidey on Earth. On the other side of the spectrum, we have this guy from Colombia. They are among the tiniest spider species. Grown-up males of this species are 0.015 inches long, tinier than your average pinhead. Females are usually a bit larger. Well, that was creepy, wasn't it?
You lie down facing the scorching sun in the middle of the desert when suddenly you smell something extremely foul. You try to crawl to the source to see if maybe someone there can help you, but all you see is a large hole in the middle of nowhere. You crawl there and stick your head down the hole. You hear something really faint down there, but it's too dark to see anything. Still, the foul smell tickles your nostrils. You turn away in disgust and stand up to get a better view of it. The hole is roughly 100 feet in diameter, with nothing around it. You've been wandering around the desert for days and just ran out of food and water, but far away, you see what looks like a small hut. You walk there for another couple of hours until you reach the outskirts of a village. A local man riding a camel tells you that you're in the Al-Mara province in Yemen's eastern region, which is quite close to Oman. He immediately takes you to his mud hut, feeds you, and gives you some water. Feeling refreshed and full, you ask the local about the hole in the desert floor. His eyes sink in and his face grows pale. He grabs you by your sleeve in silence, throws you out of his hut, and slams the door shut. You try to knock on his door once more, but he ignores you. Out ahead is the village market, where you could surely get some answers from people. You head over there, and everyone starts staring at you as if you're some kind of threat. They sense something's off about you. You put on your hood and make your way to a merchant. While you purchase some food, you ask the seller about the hole, but he refuses to sell you anything. He even pushes you off to the pathway. You make your way to another vendor and ask about the hole. At first, he's reluctant to tell you anything, but after you buy a few items from his shop, he finally concedes. He takes you to a small inn and seats you down. He tells you to keep your voice low when talking about it. He then orders a beverage for you and begins explaining everything he knows about the hole. Legends have it that the well of Barhut, which is in Hadramaut, is a cursed place, a prison for spirits. He claims that any object that goes near it eventually disappears. The server comes back with 2 refreshing drinks, and the man quickly stops talking. As soon as the server leaves, he resumes telling you about the well. The reason why people were avoiding you when you mentioned the well was because it's believed that it brought bad luck to anyone who was near it. They were even able to feel it through you. The man tells you that he doesn't believe in such superstitions, but you want to find out more. At night, you head back to the well to find out if what he said was true. You sit down next to it and concentrate all your senses. It's quiet, nothing but the desert wind brushing against the sand. You hear something that sounds like a whisper coming from the hole, as if calling you to go inside. You get up from your meditation and walk towards the hole. The sound gets louder, but you still can't make anything of it. You stick your head down the hole to listen while holding your breath, but it just sounds like gibberish. The next day, you get some rope and pikes and wait till nightfall to prepare for the next step, descending down the hole. Nighttime comes again, and you set up the ropes and tie them around a tree. You climb down while holding the rope with one hand and a torch with the other, and scale down. You try to breathe through your mouth, but you start to feel like you need to catch deeper breaths the lower you go. The hole is believed to be around 850 feet deep, but you were only able to go down around 20. You didn't expect it to be that deep. You start climbing back up, but you decide to drop the torch into the hole to see how far it goes. You see the flame getting smaller and smaller as it disappears into the darkness. Maybe the man was right, just village folklore about something they can't explain. Scientists claim that the hole is millions of years old and has practically no ventilation. Even though it's been around for such a long time, it remains as mysterious today as it's always been. You're walking in Siberia, looking out for some reindeer, when suddenly you hear a loud explosion from the distance. All of your reindeer scatter around, and you're too much in a frenzy to collect them. You run to the source of the blast and find a huge crater in an area you just passed through. In August 2020, a massive hole was discovered in Siberia, Russia, being around 100 feet deep and around 65 feet wide. The local residents and researchers were stunned to find it there. This is the 9th hole documented in the region since 2013. You call the local authorities, and a huge team of scientists arrive with weird-looking scientific equipment. They claim this crater is the biggest one they've seen so far. Most of these craters were found by accident when people went on non-scientific outings by helicopter or by hunters and herders. Scientists aren't able to wrap their heads around it, but they knew exactly where to start. Permafrost, the thing that covers 2/3 of the whole country's territory. Scientists believe that by studying the permafrost, which contains certain chemicals, we can find out why these craters are popping out. Samples of the craters contain a lot of chemicals, but most notably, methane. Scientists took plenty of samples of the frozen soil from the ground and the ice. They had to descend down the crater to collect most of them. And within 2 years, these craters end up turning into lakes. According to their studies, the gases, which are mainly made up of methane, accumulate in the upper layers of the permafrost, and they can come both from the deep layers of the earth and those close to the surface. These gases end up getting trapped in the frost as they accumulate, creating enough pressure to burst through the frozen ground. They claim that these giant holes are a result of the growing temperatures. But that's just one theory. They're still not really sure how they could have formed. But because most of these craters form in remote areas of the Arctic and take years to shape, no one really talks about them. You're fast asleep in the city of Fukuoka, Japan. At around 5 a.m., you hear a loud explosion and feel the ground shake. Japan is prone to earthquakes and tsunamis, so you're prepared for the worst. But the ground isn't rumbling and the building isn't shaking anymore. You check the power, and nothing. The whole apartment and neighborhood is completely dark. You look far out from the balcony and see a huge hole in the middle of a 5-lane road. You leave the building and join the crowd gathering outside. The hole is about 65 feet deep, and it swallowed everything around it. The traffic lights, sidewalks, and a bus stop are all gone. Even parts of buildings are destroyed, leaving the support beams still standing. The whole subway system is totally dysfunctional, and about 800 households are experiencing blackouts. Even the airport and subway had a bit of it. The local authorities evacuate the entire area in case more sinkholes or gas explosions occur. A few days later, it's all fixed. It only took the Japanese engineers and contractors 48 hours to fill it up, and a week to reopen the road to the public. The explosion might have been caused by some construction on a subway line, but the sinkhole is sinking again. People noticed that the road seemed to decline by about 3 inches in heavy traffic. But with quick maintenance, Japan can fix anything in the fastest way possible.
You step on the surface of the moon. It's unusual. You definitely feel lighter here, and it's easier to walk. You decide to check out that obsessive idea of yours. Jump on Earth's natural satellite. And even despite your bulky spacesuit, you literally fly up into the air. Woohoo! Anyway, you continue your walk on the surface of the moon when you feel something strange. The ground under your feet is it shaking? It feels as if an earthquake has just started on the moon. But that's simply impossible. Or is it? Surprisingly, your gut feeling hasn't let you down this time. Moonquakes do exist. In fact, there are 4 types of moonquakes that are strong enough to be detected from a large distance. There are deep moonquakes occurring more than 430 miles below the surface. Then there are meteoroid impacts. Thermal quakes occur when the frigid lunar crust expands. It happens when the morning sun illuminates the satellite after a 2-week-long deep freeze lunar night. And there are also shallow moonquakes. They're the only ones that are similar to earthquakes on our planet. Shallow moonquakes happen 12 to 19 miles below the surface, and they're the most powerful and dangerous. Between 1972 and 1977, the Apollo seismic network recorded 28 such moonquakes, and some of them measured more than 5 on the Richter scale. On Earth, such an earthquake is strong enough to crack plaster and move heavy furniture. Plus, shallow moonquakes are very long-lasting in compared to earthquakes. Once they get going, they can continue for up to 10 minutes. As for the average earthquake, it typically continues for 10 to 30 seconds. Scientists are still not sure what causes shallow moonquakes, and even where exactly they occur. One of the theories is that moonquakes happen at the rims of large, relatively young craters that probably slump from time to time. Interestingly, the Moon and Earth aren't the only places where earthquakes occur. No, scientists have recorded quakes, tremors, vibrations, and shakes in other regions of our solar system too. Let's take Mercury, for example. A few years ago, scientists discovered that this planet was shrinking, and that's why it seems to be so tectonically active. Or Venus. This world is a tectonic puzzle for experts. At the moment, Venus has no tectonic plates, and it might have never had them. But its surface has folds and faults and looks as if it could have tectonic plates. On the other hand, these features might have appeared because of other processes, for example, volcanic activity. But even though we haven't observed any Venus quakes, scientists believe they could detect them since their vibration seems to ripple through the thick atmosphere of the planet. Now, Mars. We know for sure that this planet is seismically active. NASA's lander placed a seismometer on the surface of the red planet, and in 2019, it managed to measure its first Mars quake. After that, the lander continued to record quakes, but they were so weak that if they happened on our planet, they'd be completely covered by the background noise of Earth's oceans. But a space body doesn't have to be a full-fledged planet to have active tectonics. Let's take Pluto. This dwarf planet is geologically active at the moment. In 2014, NASA's New Horizons spacecraft was flying through the Pluto system when it recorded complex geological features on this dwarf planet. Scientists concluded that Pluto might have quakes, or should I call them Pluto quakes, when its liquid water ocean freezes and thaws beneath the dwarf planet's icy crust. Jupiter's moons, Europa and Io, as well as Saturn's moons, Titan and Enceladus, are also geologically active despite their small size. Their features range from volcanoes and water plumes to potential subsurface oceans. Now, I bet you don't know these cool facts about earthquakes that occur on our planet. There's one place on Earth where a whopping 90% of all earthquakes occur. It's called the Ring of Fire, and it stretches around the Pacific Ocean from New Zealand all the way to South America. Looks to me more like a horseshoe. Anyway, experts claim that these countless earthquakes are caused by the abundance of volcanoes in that region and the constant movement of the tectonic plates. Around 500,000 earthquakes happen on Earth every year, but many of them occur very, very deep in the Earth's crust, and only special equipment can detect them. We feel around 20% of earthquakes, and only 100 of them can cause damage. The largest recorded earthquake occurred in Chile in May 1960. It was a magnitude 9.5 on the Richter scale. It was truly devastating. During that earthquake, seismographs detected and recorded seismic waves that traveled all over the world. They shook the planet for many days. As for the most powerful earthquake that occurred in the U.S., it was 9.2 and happened in Alaska. By the way, Alaska, along with California, is the most earthquake-prone state in the U.S. and one of the most seismically active regions in the world. A magnitude 7 earthquake occurs there almost every year. A mega-earthquake can actually shorten the length of a day for the entire planet. NASA claims that really large earthquakes can shift our planet's axis and, thus, change the duration of a day. Now, of course, you won't notice it since this change is measured in microseconds, and 1 microsecond is 1/millionth of a second. Scientists think that the 9.1 Sumatra earthquake, which occurred in 2004, shortened the day by 6.8 microseconds. Now, not even the best specialists can predict an earthquake. That's mostly because the mechanisms that trigger earthquakes are extremely deep underground. But these days, people have learned how to figure out a more precise time frame of when an earthquake might occur. Earthquakes can be triggered by volcanic eruptions or, let's say, meteor impacts, but most of them are caused by the movements of our planet's tectonic plates. Earth's surface consists of 15 to 20 constantly moving tectonic plates. Pressure increases when they shift, and this can make the crust of our planet break. San Francisco is moving toward Los Angeles right at this moment. The speed of its movement is about 2 inches per year. That's as fast as your fingernails grow. It's happening because the two sides of the San Andreas Fault, which is the continental fault extending 750 miles through California, are slipping past each other. So, in several million years, Los Angeles and San Francisco will be neighbors. Lakes, ponds, and canals become slightly warmer and start to stink before an earthquake. It happens because gases get released when tectonic plates shift. Most animals feel these signs and change their behavior. For example, scientists noted toads completely disappearing before an earthquake in Italy in 2009. But as soon as the natural disaster was over, they returned. Even after an earthquake is over, you might still see water sloshing around in your swimming pool. There's no need to worry. This is a phenomenon called a seiche. The water can keep sloshing around for hours after the earthquake is over. For example, the pool at the University of Arizona lost some water from a seiche caused by an earthquake in Mexico that occurred 1,200 miles away. On February 27, 2010, a massive earthquake started in Chile. It measured 8.8 on the Richter scale. As a result, Earth's crust in that region was ripped so dramatically that a city called Concepcion moved 10 feet to the west. Another earthquake resulted in the tallest mountain in the world, Everest, shrinking by 1 inch. It happened in 2015 when a magnitude 7.5 earthquake caused several Himalayan mountains to decrease in size. The Japanese used to believe that earthquakes were caused by namazu, a giant catfish that lives submerged in the mud under the Japanese islands. The fish would thrash about, causing seismic activity. As for the ancient Greeks, they were sure that a powerful sea deity, Poseidon, produced earthquakes by hitting his trident against the earth when he was angry. According to Hindu mythology, 8 elephants hold Earth in place. They are, in turn, balanced on the back of a ginormous turtle, standing on the coils of an even larger snake. And every time any of these animals moves, an earthquake occurs. The Boxing Day Tsunami, Indonesia. An undersea earthquake starts in the morning. Its tremors cause a series of tsunami waves. The largest reaches the height of the Arc de Triomphe in Paris. Unzen volcano mega tsunami. A powerful volcanic eruption triggers a landslide from a 4,000-year-old lava dome. It sweeps through the city of Shimabara and reaches the sea, setting off a mega tsunami. The Vajont Dam mega tsunami, Italy. A landslide drags 9 billion cubic feet of forest, soil, and rock into the lake. A dark wall of water covers the sky over a tiny village at the bottom of the Vajont Dam. Then, with a deafening roar, the wave overtops the edge of the dam, taking out everything in its path. Mount St. Helens mega tsunami, USA. As the volcano erupts, the upper 1,500 feet of Mount St. Helens collapses into a massive landslide. Part of this avalanche plunges down into nearby Spirit Lake, which splashes the lake waters into a series of waves almost as tall as the Eiffel Tower. Alaska's Lituya Bay tsunami. A landslide caused by an earthquake creates a mega wave. It surges over the headland and washes away trees, plants, and soil down to bedrock. Molokai, Hawaii. A third of the East Molokai volcano caves in and collapses into the Pacific Ocean. This causes a tsunami the size of the second tallest building in the world, Shanghai Tower. The waves reach Mexico and California. The Yucatan asteroid tsunami. The asteroid, which is rumored to have wiped out dinosaurs, strikes the Yucatan Peninsula. It creates a mega tsunami, the largest in Earth's history. The first wave's almost twice bigger than the world's tallest building, the Burj Khalifa. Hurricane Mitch. Mitch forms in the western Caribbean Sea. Soon it strengthens to become the 8th most powerful Atlantic hurricane ever. The storm pours 4 inches of rain per hour for 2 days in Honduras. It causes terrible mudslides and floods. Hurricane Allen. Rare and extremely powerful, the storm is one of the few to reach Category 5, the highest possible. It causes more than $2 billion in damage. The Great Hurricane. After tearing down Barbados, the storm moves on. It strips the bark off the trees growing on Martinique and St. Lucia and travels further. This horrific natural disaster lasts for 6 days. Hurricane Dorian. It's the most powerful tropical cyclone to hit the Bahamas. The hurricane flattens most of the structures on the islands and sweeps them into the sea. Hurricane Wilma. The storm occurs in the Caribbean Sea near Jamaica and heads to the west. 2 days later, it gathers enough power to turn into the most intense hurricane ever recorded in the Atlantic Ocean. Hurricane Patricia. A regular storm develops a well-defined eye and turns into a Category 5 hurricane within a mere 24 hours. At one point, it travels faster than a Ferrari moving at its top speed. It makes Patricia the world's most intense tropical cyclone ever recorded. Kamchatka earthquake. It happens in the early morning 80 miles away from the shores of Kamchatka. The earth tremors produce a tsunami. The first 2 waves are catastrophic, up to 60 feet high. The third one's much weaker. Valparaiso earthquake, Chile. It happens at about 5 a.m. along the boundary of 2 tectonic plates. The tsunami, triggered by the earthquake, wipes out 620 miles of Chile's coastline. Tohoku earthquake, Japan. The first earth tremors start at a great underwater depth. The earthquake is so strong it moves Japan's main island. It shifts the planet on its axis by up to 10 inches and increases its rotation speed. The disaster also triggers a tsunami with 133-foot high waves that travel 6 miles inland. Indian Ocean earthquake, Sumatra. A rupture along 2 tectonic plates sets off an undersea earthquake. It begins at about 8 a.m. near northern Sumatra, Indonesia. It makes the planet vibrate nearly a half inch and sets off earthquakes all over the world up to Alaska. Good Friday earthquake, Alaska. The most powerful earthquake recorded in North America lasts for 4 minutes and 38 seconds. A 600-mile-long crack causes terrible landslides and a 27-foot tsunami. Areas 200 miles away get raised by 30 feet. Other places permanently drop 8 feet. Valdivia, Chile. The Great Chilean earthquake starts in the afternoon and lasts for no less than 10 minutes. The disaster affects an area the size of California. It triggers tsunamis that reach the shore of Hawaii, Japan, the Philippines, Australia, and New Zealand. The average tornado usually lasts less than 10 minutes, but there are exceptions. El Reno tornado. It's considered the world's largest tornado based on width. At its peak, the twister reaches 2.5 miles across. The Perryville tornado, U.S. It occurs at about 2 a.m. and starts with snapping hardwood trees and breaking down stone constructions. Then the whirlwind becomes stronger. It levels 2-story buildings, flips and tosses cars as if they were toys. Bridge Creek Moor tornado. When the twister gets into the town of Bridge Creek, its width is at its peak, 1 to 1.5 miles. The wind speed of the tornado reaches more than 300 miles per hour. This natural disaster causes $1 billion in damage. Manitoba, Canada. An outstanding tornado rages for nearly 3 hours. It breaks tons of trees and utility poles, damages roads and farmhouses, but miraculously misses every town on its path. Tri-state tornado, U.S. The world's longest-lasting single tornado travels 220 miles through Missouri, Illinois, and Indiana. The average tornado's path is usually no longer than 5 miles. Tupelo, Gainesville, U.S. An outbreak that consists of at least 12 single tornadoes wipes out everything on its way. The accompanying rainstorms also trigger severe flash floods that make matters even worse. Valjean landslide, Italy. At 10 p.m., a landslide with a volume of 100 Great Pyramids of Giza breaks off from the top of Monte Toc. It falls into the Valjean Dam reservoir, producing a tsunami wave taller than the Golden Gate Bridge. Yunnan, China. An avalanche of rocks, stones, and mud, so big it could fill up Sydney Harbor, forms a dam on the Jinsha River. The Hida River, Japan. Triggered by a rainstorm, 300,000 Olympic swimming pools of debris flows down before getting stopped by another, earlier landslide. Along the way, the landslide sweeps 2 buses off the road. Peru. A rock slide dams the Rio Montanero, a long river running through the center of Peru. The whole process takes no more than 3 minutes, which means the landslide moves at a speed of up to 87 miles per hour. It also leaves a trail of debris 5 miles long. The Usoy Dam, Tajikistan. Set off by a magnitude 7.4 earthquake, the rockslide falls into the Murghab River and blocks its flow. That's how the Usoy Dam, one of the tallest in the world, appears. Mount St. Helens, USA. At 8:30 a.m., after much buildup, a volcanic vent finally gives way and sets off a catastrophic eruption, which makes the entire north side of Mount St. Helens fall away. It's the world's largest recorded landslide. North Bonneville, U.S. In the middle of the 15th century, a great earthquake occurs. An incredible amount of debris rushes down from Table Mountain. It covers more than 5 square miles and blocks the Columbia River with a dam 200 feet high and 3.5 miles long. It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground. So if you see a rainbow, that means you're in for some good luck. But if you see a deep-sea fish, this means that something tragic is about to happen. Let's have a look at ancient lores and what they might mean IRL. In August 2020, people started out their day just like any other in California. It was sunny, so they decided to soak in the sun at the beach. They were snorkeling and kayaking when one of them spotted something out of the ordinary – a doomsday fish. The creature was 12 feet long. It's known as an oarfish, and only about 20 of them have washed up in California since 1901. Oarfishes live in obscure parts of the ocean, but why are they linked to doomsday? Japanese folklore says they are harbingers of disaster. These creatures were once thought to be sea serpents, and they are known as the messenger of the beautiful palace at the bottom of the ocean. The thing is, they only left the beautiful palace to warn humans about a disaster. That's why they're mainly known as bad omens. And when you see one, you can expect to see a tsunami or an earthquake right after. Even oceanographers confirm that this is a famous association. Now here's where it gets weird. The oarfish washed up near San Diego shores on the 10th of August. And then, on the 12th of August, a magnitude 4.4 earthquake hit Los Angeles. That's not the first time it happened. In 2011, in Japan, about 20 oarfishes were found stranded on the beaches and coastlines of Tehuco. Right after that, a magnitude 9 earthquake and tsunami hit the city. Something similar happened in the Philippines. On February 8, 2017, an oarfish was seen. 2 days later, a magnitude 6.7 earthquake struck the city and its nearby provinces. Sure, there is no way to prove both events are connected. The Seismological Society of America is adamant in saying that this is pure superstition. A recent study analyzed the coincidences and concluded that this association is statistically untrue. Can we say this happened literally out of the blue? Humans have historically noticed animals acting strange right before natural disasters. Earthquakes, floods, even tsunamis. It's like animals can sense something we can't. In fact, there's a lot of science to back it up. Studies show that animals can detect subtle environmental changes, like shifts in the Earth's electromagnetic field or infrasonic sounds, things humans wouldn't notice. This happens because most animals have a wider hearing range than humans and have extra sensitive senses that help them detect gases emitted from the Earth. This theory got famous after the tragic tsunami that destroyed several cities and villages in Indonesia back in 2004. Most man-made warning systems shut down and didn't serve their role of warning humans about the disaster. Sensors were out of action due to maintenance, while other coastal areas simply didn't have any tsunami warning systems. Terrible timing, I know. Still, minutes and hours before the 30-foot wave hit the city, some animals sensed the danger and fled. Eyewitnesses say that elephants ran for higher ground, while flamingos abandoned their low nesting areas and dogs refused to go outdoors. A local reported that he saw a herd of buffalo turning their ears toward the sea and then stampeded to the top of a hill. A lot of the people that survived the tsunami used animals as their warning systems. Now, this is not the first time humans have relied on animals to save their lives. The first official account of when it happened dates back to 373 BCE. I wasn't around then, but the Greek historian Euclides reports how the local population saw rats, weasels, and snakes running from the town before a massive earthquake hit. So, what exactly is it that animals can sense that humans can't? To find that out, scientists put biologging tags on cows, sheep, and dogs living in Italy. For about half a year, they tracked the animals. During this time, official statistics recorded over 18,000 quakes in the region. The most shocking information was that animals began to change their behaviors up to 20 hours before an earthquake. Before an earthquake, something called positive holes happen. It's an electric charge that flows from the crust up to the surface of the Earth. They can change the air molecules above where they appear, and animals can pick up on them. There's also evidence that animals might sense changes in groundwater. Before earthquakes, the stress in fault lines can release radon gas, which could alter the chemistry of groundwater. Animals that rely on it might detect these changes and react. Birds are also super sensitive to shifts in the Earth's magnetic field, which can change just before a quake. Another research happened near Mount Etna. Located in Sicily, Italy, it's one of the most active volcanoes on the planet. In 2002, a massive eruption wiped out a ski lift, 2 hotels, and a series of shops located near Etna. So, over the past years, a group of researchers decided to track goats living next to Etna. Their big aha moment came in 2012, when the goats started to act erratically 6 hours before Etna started to spew lava. These researchers were able to retrospectively predict around 7 disasters over the course of 2 years, all thanks to these goats. Back in 2014, a group of scientists studying golden-winged warblers in Tennessee noticed something odd. The birds had taken a detour from their customary breeding grounds. These little birds flew 435 miles from the Cumberland Mountains, where they had just arrived, after flying over 3,000 miles from South America. Right after the birds left, a series of more than 80 tornadoes struck the area, causing over $1 billion in damage. What these birds did is something scientists call an evacuation migration. They sensed the tornadoes coming from over 250 miles away. Infrasound is a big disaster giveaway. Storms and tornadoes make very strong infrasounds that can travel thousands of miles from the storm. Now, infrasounds are low-range frequencies, anything ranging below 20 Hz. With our normal set of human ears, we would never hear this. We have an average hearing that ranges from 20 Hz to 20,000 Hz. That means you can hear something like a very, very low bass note or as loud as the buzzing of a mosquito right next to your ear. An elephant's hearing range can reach below 20 Hz. This would make elephants expert at detecting disasters. Scientists also think that detecting infrasound is what helps birds dodge storms when they must cross the ocean. You see, the Pacific Ocean is known to not be at all passive. Although courageous humans venture to cross it, they're usually met with severe storms and conditions that their satellite instruments sometimes can't detect. Meanwhile, there's an ongoing project from France's National Museum of Natural History that is tracking more than 100 birds on their annual crossing over the Pacific. With the help of the International Space Station, they're trying to understand how these little creatures respond to natural hazards en route. But not everyone's convinced. Some scientists argue that while animals might be sensitive to environmental shifts, predicting disasters based on their behavior is too risky. The U.S. Geological Survey has pointed out that many reported cases of unusual animal behavior before disasters are anecdotal, meaning stories and reports, and large-scale studies have yet to prove a direct link. Although humans don't have these super capabilities of predicting disasters, we have some things that might help us. Notice this. The next time you're in a place where lightning is going to hit, your hair will give a sign. If it stands on end, this means that lightning is aimed toward your beautiful person and is about to hit you. So run, find shelter, get inside a house. That's the best you can do in a situation like this.
On September 16th of 2023, without warning, the Earth began to hum. A low, strange vibration reverberated through the crust. This set off seismic alarms all across the globe. For 9 days straight, the planet was pulsing with this horrifying rhythm, and scientists had no idea what was going on. Meanwhile, the total disaster was happening in Greenland. It wasn't an earthquake. They knew that much. They could tell it by the rhythm. Since we all live on giant tectonic plates, they constantly move and slide on magma like icebergs on water. Sometimes, as they move, they can rub against each other or collide or break. In any case, all this causes an incredible release of energy that sends shockwaves through the ground. That's when we feel the ground literally shaking, and it's what we call an earthquake. These vibrations we feel are called seismic waves. Seismometers pick them up as pings or rumbles. In a typical earthquake, they create a bunch of different frequencies. It's a crazy chaotic mix of low and high frequencies, like smashing every piano key. What was weird about the Greenland event is that the signals weren't like that at all. It was a steady, single-frequency vibration, as if some ancient machine was stirring beneath the Earth. It's like one piano key being struck over and over, creating a doom-like, repetitive sound. Turns out, what they were hearing wasn't the noise of tectonic plates going wild. It was a phenomenon seismologists had never seen before. The days passed, and the mysterious noise just kept going. The vibrations repeated every 90 seconds, echoing around the world. The hunt for answers was growing more desperate. Seismologists had no idea what they were dealing with. They had to gather a huge international team of 68 people from 15 countries. All these scientists were gathering seismic data, satellite images, and doing some advanced math for several days, until they finally realized who the culprit was. Water. It all happened in a remote, desolate region of East Greenland. This place is full of fjords, narrow inlets of the sea between high cliffs, kinda like deep water-filled valleys surrounded by towering rocky sides. In this area, surrounded by jagged peaks and icy waters, the air was still. The landscape seemingly frozen in time. Nothing here changed much for years, until one day. A colossal landslide has unfolded in the Dixon Fjord. One of those steep mountainsides towering over the fjord at almost 4,000 feet high collapsed in a massive landslide. Picture a huge chunk of this mountain crumbling and crashing down into the fjord below. This sent a deluge of rock and ice crashing into the water. The impact was just apocalyptic, 882 million cubic feet of debris. That's enough ice and rock to fill 10,000 Olympic-sized swimming pools, or 10 Great Pyramids of Giza. And all this nightmare hurled into the water with such force that it kick-started a tsunami about 360 feet high, taller than the Statue of Liberty, into the air. What's crazy is that this incredibly powerful wave was trapped in the fjord by narrow cliffs, unable to escape. It's like water sloshing in a closed bathtub. For 9 days, the mega tsunami continued to churn through it. That's why we heard this endless hum. It was a rhythmic back and forth of the water slamming against the walls. The shockwaves were rippling deep into Earth's crust, vibrations so strong that they were picked up by seismometers around the globe. This was a phenomenon so rare, so unprecedented, that it left scientists stunned. It turned out to be a perfect storm of elements. A glacier, weakened by years of warming, could no longer bear the weight of the mountain above. This collapse was inevitable, and the chaos literally shook the Earth to its core. And people often hang out in this area with cruise ships passing by. We're lucky that no lives were lost in the disaster. It was a close call though. A tourist ship stranded in the area just 2 days before narrowly escaped the tsunami's reach by pure luck. But it doesn't mean there were no losses. The waves destroyed a nearby Inuit site, which was there untouched for over 200 years. They also swept away the huts at a research station that were about 43 miles away. The vibrations traveled from Greenland to the South Pole in less than an hour. That just shows how dangerous events like this can be. And this isn't the only place where such catastrophes are happening. In the beautiful California community of Rancho Palos Verdes, the ground is shifting so quickly that it's tearing homes apart. The land there has always been kinda unstable. It has some unique geology. It's built on soft, clay-rich soil and sits on a geological fault line, which makes it prone to landslides. This means that this land is prone to slow natural shifting over many years, even when no crazy weather is happening. It's been like this for decades, but usually it's slow and pretty manageable, like about a foot a year. Imagine a tree that you played with as a kid moving 20 feet to the left as you grow up. For decades, residents adapted. They built their homes on adjustable beams. This helped the houses to move with the land, and that strategy worked well until now. Recently, things have been getting much worse in the community. Now, the land is moving by a foot in a single week. That would be like if the same tree moved almost 960 feet since you were a child. The past 2 years have also caused some heavy rains, and the weather has been getting worse. This increased water content in the soil. The land became heavier and more prone to rapid movement. Now, this once idyllic seaside escape turned into a disaster zone. Cracks have appeared in closets, gardens, and roads, growing larger with each passing day. Streets that were once smooth are now buckled and twisted, with roads turning into a crazy theme park. Houses that once stood firm are being ripped from their foundations, some of them split in half. One of the houses had its front door 8 feet off the ground. Entire neighborhoods have been plunged into chaos. Utility companies had to switch off gas and electricity indefinitely to prevent potential disasters. The hardest hit is the coastal neighborhood of Portuguese Bend, where residents are living on the edge, literally. It always had amazing ocean views and cool sea breezes, with horses and peacocks still wandering the tree-lined streets. But now, it's like an earthquake hit. Only this time, the earth isn't stopping. For many, this place feels like paradise, if only the land would stop shifting beneath their feet. So the locals don't give up. Some of them had to leave, but many are determined to stay and fight, despite the destruction. But they still have to pour in hundreds of thousands of dollars to save their properties. People have installed generators to keep the lights on and set up sewer systems and pumps to drain the groundwater causing the landslides. Some say that the only way for these neighborhoods to survive might be to go completely off-grid, installing power walls to store energy and stuff like that. People are trying their best to run the sewer system off generators. They hope that they could get rid of this water in the soil that's causing these hellish landslides in the first place. They're determined to fight, but they will need help and support from the government to fight this disaster. Landslides are actually more common across the US than many might think. And new maps and data show that tons of people in the country might be in danger. Scientists managed to create the first very detailed, very cool map that shows where these landslides might happen, county by county. It's based on a lot of data and the history of 1 million previous landslides. They say that nearly 40% of the United States is at risk of experiencing landslide activity, which could lead to some insane catastrophes in certain areas. Luckily, now both residents and engineers can keep this in mind. But all this shows how vulnerable we are to natural disasters and how we should always stay alerted.
Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts use equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes, just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour, so it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest the storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities.
This is John. John seems to attract all kinds of bad weather and natural disasters wherever he goes. See for yourself. One day, John notices his dog is restless. The pooch keeps scratching the entrance door and wandering around the house. He even tries to hide in the corner, howling and barking. When some mugs start to clink in your cupboard, John realizes what it means. The noise is produced by foreshocks, mini earthquakes leading up to the main event. Earthquakes often happen in clusters. After a few weak quakes, a much bigger one is likely to be on the way. Sometime before the disaster strikes, people might notice bizarre blue lights. Some of them seem to be coming out of the ground. Others are hovering in the air. These are earthquake lights. They may appear days or mere seconds before the ground starts shaking. Now, John is walking along the ocean shore. Suddenly, he sees the water retreat from the beach. Really fast. Uh-oh. John, run away as quickly as you can and find some high ground. A tsunami is coming. And your life might depend on how fast you react. If John spots a bizarre and unexpected rise in sea level, it can be another sign of an approaching tsunami. This happens in 40% of cases. The incoming water is the first tsunami wave. The second one, way larger, will come in about 10 minutes. John can also notice seawater bubbling, swirling, and creating bizarre patterns. It's another sure sign a tsunami is near. John feels there's something strange about the sun. Through his special super dark sunglasses, he sees that there's some uneven flares around the star's contour. If these bizarre rays are accompanied by auroras all over the world, they're a sign of a solar storm. Such storms are usually caused by disturbances in the sun's magnetic field. In this case, the bursts of gas and radiation on the surface of the sun get so massive and powerful
that they can even reach our planet. Luckily, solar storms aren't really dangerous for people, but they can mess with electricity and even cause blackouts. The sky over John's head is darkening and turning ominously green. Something hits him on the forehead. Ouch! He picks up the offending object. It's a hailstone, but it's not that cold outside, and it's not raining. Soon, he hears some noise. It's approaching rapidly and turns into a loud roar. It sounds as if a freight train is moving towards him, but it's not a train. It's a tornado. The funnel isn't visible behind a cloud of debris, but John can't mistake this rotating column of air for anything else. Are you on the road, John? Then get as far away from your car as you can. Fast! Find a ditch, lie down in it, and cover your head. Oh, you're inside? Then get away from the windows and hide underground if possible. And please, John, be very careful if you spot some conically shaped clouds. Those mean severe storms. And if you notice that such a cloud starts spinning around, immediately search for shelter. The cloud is transitioning into a tornado right in front of your eyes. On the bright side, John should only worry about warm conical clouds. Cold ones are totally harmless. The only problem is to figure out the temperature of the cloud he sees. Duh! Ah, look, John just spotted some weirdly shaped trees. They look like the letter J and grow on a slope. It means the ground under John's feet is likely to be unstable. If he keeps wandering around, it can cause a bad landslide. Square waves appear when two different wave patterns crash into each other. This phenomenon does look kinda awesome. No, don't go into the water, John. Keep watching it from the shore. Cross currents in that spot can easily pull even a skilled swimmer under the surface. John keeps walking along the shore. At one point, he sees wild, choppy waves carrying ocean debris and seaweed. This time, he stays out of the water. He knows it can be a sign of a strong rip current. It can carry a swimmer far away into the ocean. How about a walk in the park? John likes this idea. The sun is shining and the sky is so blue and beautiful. Suddenly, he spots a rapidly growing vertical cloud. At first, it looks bright white. But as it approaches, alarmingly fast, it becomes dense and inky. The sky is darkening. It's getting windy. That's when the guy notices that his hair stands on end. It's his cue that he's about to get hit by lightning. At this very moment, positive charges are rising through his body. They're reaching towards the negatively charged part of the storm. If he doesn't react fast, these charges will meet. There's nowhere to hide, so John should crouch down and try to make himself smaller than the objects around him. Oh no, John, don't lie down on the ground. It may be damp and thus a great conductor of electricity. There are other signs that scream danger during a lightning storm. John's palms may begin to sweat. He might hear bizarre crackling and buzzing sounds coming from metal objects nearby. His skin can start tingling. There might be a strange metallic taste in his mouth. Plus, John is likely to smell chlorine. That's how ozone smells. Electrical charges split the molecules of nitrogen and oxygen, which are the main gases making up the atmosphere, into separate atoms. When these atoms come together again, some of them produce molecules made up of 3 oxygen atoms. That's ozone. We can smell it during a thunderstorm because downdrafts bring this gas from high altitudes to your level. Some bugs can feel a storm coming. They get ready for a natural disaster by freezing. So, when John notices that insects around him look drowsy, he knows to get ready. Oh, and bees can predict heavy rainstorms. These critters begin to work much harder the day before it starts raining. While walking next to the river during a period of heavy rains, John hears a roaring sound. He feels paralyzed with fear. It's likely to be a flash flood moving in his direction. Indeed, he soon sees debris coming down with the flow. The water is rapidly changing its color, becoming muddier and darker. Flash floods are very, very dangerous. Take care of your safety immediately, John. Another day, John sees a spectacular wall cloud. It seems to be stretching for up to 5 miles. In the best case scenario, it's just a severe storm coming. But if the wall cloud begins to move in a circle, it's a sure sign of a tornado. John is walking across a snowfield in the mountains, listening to the sounds the ice under his feet makes. The noise is kinda hollow. Quickly quickly check whether there are cracks around your footprints, John. If so, the chances are an avalanche is about to happen. Soon, John sees an avalanche moving in his direction. He does his best to get off the slope. In most cases, he could probably outrun it by heading downhill and then veering sideways, but not this time. He realizes he doesn't have enough time and heads for the nearest tree. If John keeps holding on to it really tightly, the avalanche might not pull him along. But if this doesn't work, he should try to swim up to the snow's surface while the avalanche is still moving. On a pretty nice summer evening, John notices leaves with soft stems droop all of a sudden. It might be because of an upcoming storm. Right before extreme weather arrives, the air usually becomes more humid. Leaves also get damp and heavy, and the wind easily flips them over. John lives in a pretty old house and is used to having cracks in the interior walls, but one day, he notices that some of them have widened. And look, there are a few new ones. It's an alarm bell. He lives in an area with loads of limestone, so new cracks can mean a sinkhole is about to open next to his house. John is hurrying home, trying not to waste time admiring shelf clouds. They look like something from a sci-fi movie. They form when warm and moist air gets caught in a thunderstorm updraft, and these ominous clouds most often mean a storm is coming.
Marriage is not only about happiness, mutual support, love, and friendship. Marriage is also about trials, crises, and storms. And this Swedish couple survived several storms during their honeymoon. Literally. Not screams, insults, and drama, but real hurricanes, fires, earthquakes, and other natural disasters. This is a really cinematic love story. Newlyweds against nature. Meet Erica and Stefan. They met in Stockholm while working on a joint project, parted, but started chatting with each other on social networks. Their long-distance communication lasted for several years before Stefan decided to ask the woman out on a date. And it's worth paying tribute. It wasn't a typical date in a restaurant or in a park. Stefan suggested that Erica fly with him to go diving in Egypt. They realized that they both loved to travel and finally fell in love with each other. After a fabulous wedding and the birth of a beautiful daughter, the couple decided to go on a 4-month honeymoon. The tour was impressive. From Sweden to Indonesia, then to Australia, New Zealand, Japan, and China. They didn't expect that the trip would turn out to be a real adventure where safety was not guaranteed. At first, they got stuck at Munich airport. All flights were delayed because of a severe thunderstorm. In Bali, Indonesia, they went to a high mountain with their little daughter. A strong wind began to blow at the top. It tore off the roof of the tourist bus where our heroes were sitting. Fortunately, no one was injured, and there were no other problems. But at that moment, it was just a teaser of the coming disasters. The couple arrived in Australia, where a wildfire first started near the city of Perth. Stefan and Erica didn't want to cough up thick smoke, so they quickly left for the city of Cairns. It was during that period when a ferocious cyclone began there. The storm was so strong that the Australian Red Cross Service provided shelter for 2,500 people in the mall. And there, another problem began. Imagine 2,500 people in a big, hot room without electricity while a hurricane is raging around. Oh, and there were only 5 toilets in the entire building. How nervous do you think people were? Eric and Stefan recall that some guys started fighting because of stress. The tension was getting stronger, but fortunately, the mall guards kept the situation under control. Wildfires, hurricanes, it seems that something is missing. Oh yes, what about an earthquake? The couple faced 2 earthquakes during their honeymoon, one of which happened in Japan in 2011. They went through all this together with their little daughter. Just imagine how their daughter was amazed by all these adventures. Such a trip strengthened their marriage. Of course, after natural disasters, any domestic quarrel would seem like a mere trifle. Erica admitted that in crisis situations, Stefan fully justified her trust and behaved as she had hoped. Oh, how sweet. What if we create tours for married couples who are planning to divorce? Survive the storm, fire, earthquake, and flood together, and then think again whether you should leave each other. Imagine that you've gone through several natural disasters in your entire life.
Now the question is, are you lucky because you've survived, or are you an unlucky person because you've run into such troubles? It depends on how you feel about it. For example, there's a woman, Dana Weiland, who lives in California. She has survived several disasters throughout her life and continues to smile. And more recently, she's faced another disaster, wildfires in her home state. But let's take it in order. In 2005, Dana Weiland lived in New Orleans. And if anyone doesn't know, that year, Hurricane Katrina destroyed many houses in this and other cities. Dana's house was no exception. According to her, the lower floor of the house was completely flooded with water. Of course, she had to give up everything and evacuate. Dana and her family drove to Texas to a friend's place for about 20 hours. 1 month later, Hurricane Rita arrived there, and Dana and her family evacuated again. It looked as if nature was following her around, but our heroine was not one of the timid ones. Several years later, she faced another disaster, Snowmageddon. This was when a huge amount of wet, cold snow flooded cities and roads. Strong wind, blizzard, and endless snowfall. All traffic stopped. The lights turned off. The streets were empty. Dana sat for 11 days without electricity during this snow apocalypse. And after all these disasters, she got the exact opposite of snow. Wildfires in her hometown of Lake Arrowhead in San Bernardino County. Let's hope that this time, everything will be fine with her again, and she will meet any adversity with a smile on her face. Have you heard that lightning doesn't strike twice in the same place? Can it hit the same person twice? What if it strikes the same guy 7 times in a few hours? This is not a movie plot in a tragicomedy genre. This is the real story of Roy Sullivan, a man who got into the Guinness Book of Records for the number of lightning strikes survived. There are more than 8 million lightning strikes on Earth every day, which is about 100 strikes per second. But even so, the probability of getting struck is extremely low, 1 chance in 10 million. For Roy Sullivan, these chances were too high. For his strange record, people nicknamed him the Human Lightning Rod. For the first time, lightning struck him in 1942, when Roy was on a watchtower that didn't have a lightning rod. A bright flash of light and a powerful current discharge scarred the man, but didn't cause crucial damage to health. The next accident occurred in 1969, when lightning struck a tree near the road. The lightning passed through the tree to a car. Guess who was driving this vehicle? Roy lost control and almost drove off a cliff. Fortunately, he stayed alive again. Okay, the first time he was on the tower during a thunderstorm. The second time was on the road next to a tree, and as we know, lightning often strikes trees. This meant Roy was in a potential risk area every time. But the third time happened in his front yard. Lightning struck the transformer and caught his shoulder. The fourth time happened in 1972. Lightning struck Roy while he was working. From that moment on, the man began to suspect that this natural phenomenon was somehow attracted to his body. Maybe it was a curse, or maybe everything could be explained from a scientific point of view. A year later, lightning struck him for the 5th time. A thunderstorm started that day. Roy decided not to try his luck again and hid in his truck. And so, when the storm calmed down, Sullivan got out of the car and bam! Another lightning strike. There were 2 times left before the record. They occurred in 1976 and in 1977. Roy's bad luck spread to his wife. One day, lightning struck her too. It didn't hurt her, but scared a lot. So far, no one has broken Ray's record, but obviously, people haven't tried to do that. Okay, lightning, fires, snowstorms, hurricanes, and earthquakes. But how about tsunamis? Unfortunately, this is one of the most terrible and devastating disasters on the planet. If you survived it, you're definitely lucky. Zarul Fuadi from Indonesia survived these devastating water disasters twice. The first occurred in Indonesia in 2004. And the second happened a few years later during an earthquake in Japan. During the second time, Zarul was in the building on the 3rd floor and felt a jolt. He was shocked and immediately remembered the tsunami he had experienced before.
The tsunami hit the city, but our hero and his family survived. After this double trouble, he decided to move to his homeland, Indonesia. Despite the terrible events, Zarul looks at what happened calmly. Any catastrophe can happen to any person at any moment, but it doesn't mean you should live in fear forever. So, he focused on the bright side of life.